All right, so before we move on, I just want to also take a time to thank our supporters. We have a lot of supporters here at the AIA Los Angeles chapter. I'd first like to thank our technology intensive supporters, our friend of the conference, IBI, and our participating sponsors, Imagine It and Monograph. You will all get a time to really interact with these sponsors today at our virtual exhibit portion, which will be right in the halftime portion around 10:30 a.m. And next, I'd like to take the time to really thank our annual sponsors. They support us throughout the year, and we wouldn't be able to do these programs without them. Our first up is our gold sponsor, Gruen Associates. Silver sponsors, AC Martin, Cumming, Co-Architects, Egan Simon Architecture, HED, and Lair Architects, LA. And finally, our bronze annual sponsors, Bernard's, Collins, Muir and Stewart, KFA, Rex Engineering Group, and Sharp Interior Systems. Again, if your organization is interested in working with us and sponsoring and supporting our programs, please reach out to one of us at AIA-LA. Okay, now I'd like to hand it off to Mitra Mamari, AIA, President of AIA Los Angeles and partner at ZGF Architects. Thanks for being here, everyone.
Good morning, everybody, and welcome to our second annual technology conference. My name is Mitra Mamari, AIA. I'm the president of AIA Los Angeles, and we're grateful to have an incredible lineup of speakers and presenters to share with you today. And I especially want to thank our steering committee who've helped us organize everything. You will meet our steering committee over the course of the program. Our objective in bringing programs like this to you, and yes, hopefully in person soon, aren't we all tired of this, is to share access to specific tools and best practices that will make your architecture practice more effective, productive, and lucrative. Our goal as a chapter is to share access to the new technologies and techniques that can utilize and expand your scope of service, organize yourself internally for more equitable and productive outcomes, and to deliver more value and innovation to your clients and colleagues with data-driven design solutions. By the end of this conference, you'll learn a better understanding about how to utilize such tools as digital twins. I have no idea what that is right now. Augmented and virtual reality, and your building information models, BIM, to deliver new services and deliverables. This will be a rapid waterfall of information, so sit back and relax and open your notebooks. If you are the old-fashioned type that takes notes, with those mechanical pencils that we used to have, maybe some people don't know what those were, take in everything that's coming our way in the next couple of hours. But kidding aside, we're grateful for your presence today. We're especially thankful for all of the supporters and our sponsors. It's their direct support that helps fund and operate this chapter so that we can organize these programs and bring them to you. And now it's my pleasure to introduce to you Nicole Boulis, CM BIM, and Lauren Coles, AIA Lead AP, who will serve as your guides to frame the discussion this morning. Nicole is the practice technology leader at HED, and Lauren is a senior associate at Co-Architects and the vice chair of the AIA LA Professional Practice Committee. Welcome, Lauren and Nicole.
Thank you, Corinne, and thank you, Mitra, for that inspiring opening. Along with Mitra and the Event Planning Committee, Nicole and I are delighted to welcome you all today to the second annual Smart Buildings, Smart Cities Technology Conference. As Vice Chair of the AIA LA Practice Committee and as a project manager myself, I understand the importance that every team member keep up to date with the technologies that not only shape our buildings, but also shape our design process. With that regard, today's event has assembled top industry leaders in data-driven design, digital twins, and virtual environments. And while last year's conference focused on delivering the future, this year's event focuses on today's technologies and how to incorporate and transform buildings and cities now. Nicole, I think you're muted.
Statement of the century. All right, so the pandemic. The pandemic sparked an existential crisis for businesses all around the world. With the help of tech practitioners like myself, many firms, they chose to adapt. In the architecture, engineering, and construction industry, projects moved to the cloud at an unprecedented rate, breaking down outmoded industry silos and shifting mindsets to cloud first virtually overnight. Make no mistake about it, this kind of shift often takes years. Who knew a crisis could in part be a great accelerator for progress? And the new normal, Zoom, Microsoft Teams, digital whiteboards, and Revit cloud work sharing are fundamentals to any firm's toolkit. If anything, it proves that slow-moving giants of AEC are capable of rapid change and succeeding. A great leap forward in the era of digital transformation, and there's no turning back. 24 months later, the race is still on in every sector in brave pursuit of digital transformation. The AECO industry is no exemption, except with technology, we've been here before. In 40 years, we've mastered AutoCAD, disrupted with building information modeling, and opened the floodgates of cloud collaboration. While COVID may be a once-in-a-lifetime event, disruption of all kinds will accelerate at a rapid pace. Before COVID, AEC firms grappled with doing more with less, joining the coalition against climate change and making our world a better place. Advances in technology allow a better quality approach to solving these challenges and also expanding our services and maximizing growth. In the era of data, where data is gold, the AEC industry sits on a gold mine. Cloud collaboration accelerates our data flow, but the real wealth is extracting actionable data insights that inform design, optimize delivery, and foster positive symbiotic connections in the built environment. The heroes of this effort are the people who work in the data every single day. That's you. Today, we will dive into key enablers to visions of a smart building and city's future.
For architecture firms, technology is about communicating design intent to communities. Virtual technology systems can allow for total immersion in a designed environment, now accessible via cell phone and cardboard goggles, with new inventions happening daily. These designed environments allow clients and the public to see the design in almost reality. And augmented reality allows for incorporating experience into the real world. Imagine being able to share a new green streetscape with an AR cell phone app that when you stand at a certain location on the street, you can see a brand new vision of that location right there on your phone. This is just one example of how smart cities and buildings can be realized. And today we will expand on other solutions. Before we begin our first session, this conference means to reinforce why technology matters to design and building. We aim to connect the dots between typical processes with different and promising solutions. The goal is to impart practical wisdom while presenting instruments and tools that play different roles in supporting the design of buildings and cities. So thank you all for being here today and welcome. I'll pass it on to Nicole to introduce our first session.
All right, so on to our first segment, data-driven design. Data-driven decision-making is the process of using data to inform your decision-making process and validate a course of action before committing to it. For us, data-driven design is essentially design backed by data. So what does that actually mean? Helping us to find out and moderating our first segment is Brian Scalron, Associate BIM Director at Keough & Associates. Trained in architectural practice, Mr. Scalron is determined to develop solutions to improve efficiencies by using technology. Previous employed by an Autodesk reseller, he has implemented workflows for many elite firms across the nation, including Disney, Ramza, and now across all departments at Keough & Associates. Helping us learn all about this new buzz topic, Brian Scalron. Brian, over to you.
Thanks, Nicole. So I just wanted to add, I'm also co-chair of the AIA LA TAP, which is Technology and Architectural Practices. We're trying to bring more events about technology throughout the year to you guys. So please reach out to me on LinkedIn if you're interested. Today, we're here to talk about data-driven design. BIM is a database that we need to start using to our advantage. The traditional design process of iterative cycles of trial and error are no longer necessary. Our clients require greater precision and validation of choices. Data-driven design enables us to provide confidence that our decisions will meet the results. Data provides more certainty. Data helps team members learn quickly, and data leads to better design decisions and insights. Data reduces risk, manages complexity, and convinces. So each of our panelists today will do about a 10-minute presentation, but we will have time at the end for questions and answers. So please jot down any questions in the chat as we go. So I'm very excited to present our panelists today. First, we have Julia Fruit-Handler. Julia is an urban data analysis at IBI Group. She graduated from USC with a degree in geodesign. Her work focuses on GIS and urban planning integrations using parametric design. Julia has a strong interest in transportation planning and affordable housing. Next, we have Ian Keough. Ian is the CEO of Hypar, a cloud platform for generating buildings. Before founding Hypar, Ian was the software architect for the AEC generative design team at Autodesk. In that role, he worked on Dynamo, which Ian started in 2010 before joining Autodesk. And finally, we have Nate Miller. Nate founded Proving Ground as a business to support the industry's adoption of data-driven methods. In addition to providing consultant services, Nate's company publishes tools for systems interoperability, data warehousing, and business intelligence. All right, Julia, are you ready to go?
Yeah, I'll share my screen. Let's see. Just got thumbs up. Everyone see my screen? Okay. Hi guys, I'm Julia Fruit-Handler. I am an urban planner and a parametric designer for IBI's Quantum Group, which is a parametric modeling team. And the title of this presentation is a parametric process for placemaking, and hopefully that analogy will make sense in a moment. So what is parametric design? So that is usually the first question I get. And parametric design is a customizable algorithmic process enabling the architect or planner to efficiently and effectively process complex information, associating multiple parameters or data sets as design drivers for evidence-based decision-making. So it allows us to efficiently and quickly iterate through hundreds to thousands of different design scenarios and receive instant feedback. And I know the word algorithm is sort of a big buzzword, and it kind of tends to not mean anything. But an algorithm is really just a set of rules or a process to be followed in calculations or other problem solving, especially by a computer. So when you're putting together several different pieces of information, trying to weigh everything all together, this is an excellent way to circumvent bias and remove intuition from the equation. And hopefully this is where the placemaking play on words will start to make sense. But an algorithm is really just like making bread or like baking, where you have your ingredients, so your water, your salt, your yeast, and then you have a process. And so, first you put your yeast with your water, and then you knead the dough, and then you let it rise. So you're following a set of instructions with your inputs or your data. And in the end, you'll get a loaf of bread. And if you change the inputs or data, or if you change the process, you'll end up with a slight variation on what you had before. So let's say, you try to let it rise before you've properly mixed, then you'll have a really dense loaf of bread. Or if you add some sugar and some berries, then you end up with a muffin. And so as you incorporate new ingredients and new data, you can iterate on what you get in the end. And the other piece of information that I think is relevant is that none of this is happening in a vacuum. So while the computer or the bread is being made, someone is making that. And it's really important that it's a person who knows what they're doing and has context. So a baker is making this bread, and you want a baker who's tasted bread before and who can taste the bread after and say, yeah, I think that tastes like what it should taste like. And you need, if you're a farmer, to grow the wheat, and someone who knows what fruit is in season and who is aware of the local horticulture if you're making some kind of blueberry muffin or berry muffin, so to speak. So the important thing what I'm getting at is that you're following a set of instructions and you're incorporating information, but you're not doing it in a vacuum. You're doing it with experts who understand the process and come with context. And so with that, I really liked what Nicole said about actionable data-driven decisions. And so with that context, I'm hopefully going to shed some light on some of the projects that my team has worked on that hopefully have done that. So first, we have the LA Metro BRT Visioning and Principles Study. And this was a project with LA Metro, and we were asked to study different corridors for bus rapid transit suitability. So following along with me on my baking analogy, I have the ingredients and the set of instructions. So we're incorporating polylines and employment information, connectivity to other transit, equity, ridership on other transit lines that are nearby, points of interest, population, and so on. And then we're narrowing down from 30 corridors to 15 to 5 and so forth using data. And so they gave us, so Metro started with a list of 90 corridors. We didn't really know where they came from politicians and from TAC committees. People were just kind of drawing lines on a map and saying, yeah, we should study these. So they wanted to make sure that we were not missing anything. So we first and foremost did a gap analysis to see what the Metro provided lines were missing. We found an additional 9 lines beyond what was proposed. But the interesting thing about this was that local politicians really do know their districts and know what's good. And so this provided really important data validation that actually out of the 90, we only found 9 that were missing in the whole county. And that for the most part, it was pretty good. And then we take that pot of corridors and we're studying them using layered analysis. So educational facilities, transit supportive land use, and so on, we're incorporating many different sets of data, layering them on top of each other and adjusting the weights and priorities in real time with the clients, allowing them to assess their priorities, allowing them to see the output and the change in output as they change their priorities in real time. And whereas I think that anyone who knows LA County transportation could probably think of one or two streets that would really benefit from BRT, it's harder to say what's the 10 best. Why are they the 10 best? Quantifiably, what makes the 9th better than the 10th, and does it matter? And so then it provides us the ability to go to the public and say, here is why we are doing X, Y, Z. Sorry, that's finicky. So the next project was a project we worked on in Redmond, Washington, where they had growth requirements to accommodate 25,000 new housing units and 25,000 new jobs by 2040, which is obviously an enormous amount of growth in a short period of time. So the question is, how can we best do that most efficiently? How can we accommodate that growth? So we're looking at the new train stations that are being built, employment, demographics, VMT, walkability, a building pro forma that's been market tested, absorption rates and lease rates for the surrounding areas that are typical. And then we're incorporating that information to answer the question of where should the growth go and what will it look like? And so this first part, we're looking at where the growth will go, kind of similar to the bus rapid transit project, where we're working with the client to figure out what their priorities are. And then we're layering on development criteria using a building pro forma that's been market tested, and to tell us how many buildings, how many 4/1 stick buildings can this area accommodate, and how many 16/3 and so forth. And then finally, we incorporated a public opinion tool that allows the public to engage with a simplified version of the model, and they can tell us where they want the growth to be allocated. And then this model was then incorporated into a larger model and used as one parameter weighted against all of the other criteria that we were trying to find coalescence between. So that ended up being a really powerful way to quantify usually qualitative information, and ask the public what they think and see how our scenarios compare to their opinion. And in the end, we end up with a rezoning master plan that can quantifiably say, this is how much we need to grow, and this is the most efficient way that it can be accommodated. Layering onto that, taking it one step further, is our 15-minute city community planning project. This was a project with a large developer in Detroit. We worked in two cities, actually, Detroit and Cleveland. And kind of similar, we're accommodating a certain number of housing and land use, but we're taking it to the next level, where we're looking at a holistic neighborhood using the 15-minute city concept to define what the optimal 15-minute city would look like if a blank slate were to exist, and how we can get there based on what currently exists in the neighborhood. And so so in Detroit, there's been population decline, but they're looking to increase the population. So based on different predicted population growth, there's different absorption rates and different parcel suitabilities. So we're looking at, they wanted to create 3 different neighborhoods that each had their own distinct characteristics. And then how can we assign uses that will make a neighborhood complete, walkable, given the people the ability to get to everything they need within 15 minutes, but also have its own character. And so maybe one neighborhood is more emphasis on entertainment, and one is more emphasis on innovation. And so we're creating these program distributions, and then we're working with this development company's leasing agent to figure out ROI and figure out lease rates and amount of parking, et cetera, so that they can create a phasing strategy to implement all of this. And you can see that this gets quite complicated. So it's really important to have a clear workflow and a logic that makes sense from A to B to C. And this is just an example of a final rendering that came out of our model outputs. And finally, I want to talk about our mass timber structural prototyping, which intakes a parcel and building footprint, and it can calculate things like void cutouts and base sides and floor-to-floor height to generate sort of the optimal mass timber prototype for each parcel. And as I'm sure many of you know, mass timber or cross-laminated timber, which is very popular, is fire resistant and cost efficient and environmentally friendly. Oh, the video has not started, I'm sorry. It's become very popular. It's harder to accommodate often in the US because of a lot of strict zoning codes and so on. So looking at ways to best identify parcels that are most suitable for cross-laminated timber, then figuring out what it would look like on the parcel. What if we added 1 bay, 2 bays, 3 bays, and so forth. And so this is a much more holistic way of planning mass timber because we're looking at parcels that we know can support it, that have the zoning that can accommodate it, that are 8 to 16 floors, which is often a good size. And then once we figured out the modularity and the repeatability of it, we can then work on the facade and determine the opacity and so forth of the facade, playing with individual floors and bays, as you can see in this video. And then we can generate generate facades based on daylight studies, measure embodied carbon in the entire project, and then compare design scenarios. So an expert could, or someone who is competent in cross-laminated timber can look at hundreds of thousands of different scenarios and have the data, as you can see here, to assess the difference between all of them. And eventually we can take it into our digital twin models. And if you're interested in that, Tony Gill will be talking about that later in the day. But as you can see, we can incorporate data through the entire life cycle of a project. And that's all for me. Thank you very much.
Thanks, Julia. That was great. Ian, are you ready to go?
I should be. Let's see. I'm going to share my screen if that's okay.
Please.
You should all see what is Hypar. So good morning, everybody. I'm going to talk just a little bit today about my company, Hypar. Thank you, Brian, for the introduction, and thank you, Julia, for the fantastic explanation of algorithms, because it dovetails really nicely into what we do at Hypar. Hypar is a company that I started in 2018 after leaving Autodesk right here in Culver City. So I'm really pleased to be talking to the AIA of LA today. And so the simplest explanation that I can give of what we're doing is that, in traditional CAD, you start from a blank sheet, and whether this is 2D modeling or 3D modeling, BIM, doesn't matter. You start from a blank sheet on every project. You draw laboriously over months and months and months your project, or you model your project. And what that means is that change is expensive. You have to delete things that you've done before. You have to deal with all the consultants on your project. You have to manage the interactions between all of those. And you have to resolve those into design changes that become something you draw or something you model back in the BIM. Hypar is kind of fundamentally different. Hypar is software for generating buildings. In Hypar, you combine building systems to generate your design. Keying into what Julie was talking about before, those kind of algorithms. In our system, those algorithms are things that do things like generate an entire structural system, generate an entire mechanical system, or a facade system. And then using our web application, you can compose those together into applications that you can make available to anyone, anywhere on the planet, because it's just all running on the web and in the cloud, to generate buildings. So our primary deliverable from Hypar right now is actually full building generators. And it might sound a little bit out there to say that, but what we've identified in the last few years is that there is a large market of design build contractors and design build architects who have specialized building systems for different types of buildings, logistics facilities, manufacturing facilities, office buildings, schools, hospitals, that they've been employing sometimes for decades, and that they've encoded even sometimes in their own software, these systems as algorithms that they can use to generate layouts, full building layouts very quickly. Well, we started to partner with a number of these large global entities to encode their systems into algorithms that run on Hypar and can generate full building designs. And so it's a little bit abstract until I give you an example. We work with a customer called Obayashi, which is a 150-year-old Japanese construction company that does everything from design to construction in-house. And Yoshito Tsuji, their head of design, asked me a few years ago while we were sitting at a bar at Autodesk University in Las Vegas. He pulled out his iPad and he said, you know, one day I want to be able to just pull out my iPad when I'm sitting next to a client, and I want to be able to pull up the city of Tokyo, select a parcel, and design a building in real time, sitting there on my iPad at the bar with the customer. Can Hypar help with that? So what we did was we worked very closely with Obayashi's engineers, architects, and other consultants to encode their expertise, which has been gained over decades and decades of doing this kind of work, into systems that run on Hypar. And so those systems are everything from facade systems to structural systems. They encode the very specific nature of building in Tokyo. So for instance, in this image, the first thing that you do is actually you pick a parcel, and using a function that runs on Hypar, a system that runs on Hypar, we can automatically calculate the allowable zoning envelope for you based on the zoning code of the city of Tokyo. And then we encode facade systems that are typical of the types that they use, and structural systems with the types of sort of proprietary seismic fittings that Obayashi uses in their construction. And this idea of systems is important because every one of these systems acts like a true network systems in that it interacts with the other systems and knows when a change happens in the facade, it changes something about the structure. When a change happens in the structure, it changes something about the structure analysis. And all of those things happen in real time. So unlike deleting part of the building when a change happens and going and calling people on the phone and sending emails and everything else, these systems interact with each other to update in real time. And one of the very novel things about Hypar is the way that in working with a lot of these different customers, we've made their systems compatible with each other. We live in a world right now where we transfer Revit files to each other. Do you have the right version of Revit? No, I don't have that version of Revit. Well, I built a Rhino model. I built a SketchUp model. They don't work together. Well, in Hypar, we have one customer who is a large manufacturer of siphonic drainage systems. If you don't know what siphonic drainage systems are, they're the kinds of systems that get all the water off the roof of your building down and out to the parking lot. They're highly engineered systems. And right now, the process of designing one of these systems can take days and days because you have to have an engineer pick from a product catalog, design the system according to certain fluid mechanics that I can't even begin to understand, and then make you a bill of materials and sell that system. With Hypar, by encoding all of that logic into algorithms that run on the platform, we make that process almost immediate. They can design an end-to-end siphonic system in minutes. And what's great about this is because all the functions that run on Hypar work together, we can take that customer's siphonic drainage system and we can go over to Obayashi and we say, do you want siphonic drainage in your building? Let's just plug in their system. And their system actually routes around the structural components and adapts immediately to the changes that are being played out in that design from Obayashi. Another type of system that we're very actively involved in deploying on Hypar right now is automated space planning. So as was alluded to earlier, the impact that COVID-19 had, for instance, on the commercial real estate market was huge. And so we have a lot of customers who are renegotiating their spaces. And in the same way that we can generate structural systems or mechanical systems, we can generate automated space planning systems. So the space planning of a room and the space planning of a floor plate act like algorithms in and of themselves. So we can lay out tens of thousands of square foot of commercial office space in minutes, and we can do real-time design. And of course, because this is all running in the cloud, we can do optioneering as well. And I mentioned a little bit about the fact that everything works together, but this is a point that we should stress, especially in the context of this conversation. What these modern systems give us the ability to do is design buildings in the same way that the network of the web works, with applications passing little bits of data to each other, only the data they need to do their job. I said we pass Revit models to each other, we pass SketchUp around, we pass all these things around, and nothing quite works. We have an opportunity with systems like Hypar to define those contracts that are the interface between systems. So a structure should only pass to the next system the smallest amount of information that that next system needs. The structure should only convey its slab edges so that the facade system can do what it needs to do to generate a facade. And that's why everything on Hypar runs in effect like services running in the cloud. Every service has an API. And so when I move those structural components, the siphonic drainage system reroutes around the columns. When I move those structural components, the partition walls move, and the space, the automated space layout within that system updates in real time as well. And finally, the tools should get smarter over time. So the challenge with a lot of our data-based workflows right now, and our conception that we should be able to do things like design option generation, optimization, and machine learning with our BIM data, is that we're challenged by the fact that historical BIM data is terrible as a data source for doing that stuff, because it was built by different people and different versions of software and everything else. Hypar systems like those I just showed produce clean semantic data, which is perfect for training machine learning models. And we can even, in the interaction with the application, train models based on user interaction. So you made this little design change last time. The next time we'll predict you're going to make the same design change again and suggest it, or suggest the type of changes that are made by 99% of the other people who are using that same algorithm on the platform. And as just one example of this, and using the facade algorithm you saw before, we've actually worked again with Obayashi to develop a machine learning model that allows you to use Hypar systems to train to generate synthetic image data for facades, such that you can drag and drop an image of a facade onto the application, and it intuits the parameters for generating a corresponding facade, which is then actual 3D system deployed on a Hypar model. And with the current kind of data that we have in our environment, you can't really do that. It's very difficult to do with Revit. Hypar is really the first system built from the ground up to enable this. And all of this, everything that you've seen today, is available to everybody who wants to build on Hypar. Again, from the ground up, we've built a system that allows you to deploy your own applications. So the kind of tools that I'm showing here, although these are products that we sell in the market, you can use our SDKs and our open source software libraries to actually build your own applications using our scaling infrastructure for the cloud and our web application. So happy to answer more questions and excited to take part in the ongoing conversation here today.
Thanks, Ian. That was great.
All right. I think I'm set up. Brian, are you seeing my screen here?
Yeah, it looks great.
Great. Bright pink. Great way to start the morning. Thanks, everybody. I'm happy to be here at an LA, Los Angeles event, virtually, of course. Thank you for including me in the panel. I suppose I'm acting in the role of the non-Southern California demographic. I'm based in Omaha, Nebraska, and the current temperature is 9. And don't get me started on the wind chill. But I think what I'd like to do with my talk here is provide perhaps a few provocations up front regarding the positioning of data-driven methods. And then I'm going to highlight a few examples of how we're kind of maybe addressing some of those ideas in the context of some practical technology that we're developing at Proving Ground. Proving Ground, we're, as Brian indicated, we're a digital design consultancy, and I would kind of frame what we do as being connecting designers and builders with their data. And that might involve services and might involve kind of creating products. But to kind of get things started here, if we look at the state of the building design and construction industry today, we can observe that any given project or building will produce a deluge of data. There is a lot of it. None of it is terribly organized, as Ian mentioned. The applications of standardization is uneven across professional services and trades. But yet we're still in a position, I think, as professionals to have to negotiate these numerous, often disconnected sources of data. And it's a major area of friction in order to really create coordinated, holistic, and homogenized views of this information. And you can kind of see that growing in complexity as we think about the Internet of Things and real-time data sources, reporting systems. And I think, as we'll see later on, and how those kind of get consumed into digital twins. There's a lot of wrangling that takes place, a lot of work that goes into making these systems valuable. Amidst all of this, we have, amidst this navigation of the complexity associated with this, we are often, I think, faced with, as a profession, as interested parties in the world of technology, with an abundance of froth that leaves many of our clients, certainly, and sometimes ourselves, in search of practical substance. There's a lot of hype for technology right now. There's a lot of investment happening, and I think we're always seeing this kind of reach for, okay, what is real and what isn't. And it's one of our objectives, I think, as a group, when we work with our clients, is to figure out where can we cut through the hype and find something substantive that will allow for the application of these concepts to positively impact a given process. And I think in order to find that kind of, I guess, level of productivity, level of practical application, there's certainly more to cracking that nut than buying a piece of software or applying a piece of technology to a problem, or getting access to a data set. We often like to think of our kind of more strategic endeavors as operating at the intersection of people, process, and technology. That is to say that we not only need to find useful applications of these tools, but we also need to think about how those applications can impact the processes of a larger organizational collective, and not necessarily a singular group of experts that know one thing. And I think that's something that is really really important for impacting a business. We often see in organizations limited expertise in computational tools, in software development, and even in the ability to kind of wrangle and analyze data. When we talk about a digital transformation as enabled by something like a data-driven process, this has implications on the work of not only the kind of experts or the early adopters of the software, but also the general sort of staff makeup of your teams, the project managers that are organizing your work, and the executives that have to manage a business. So that's something that we're very kind of always kind of wrestling with and thinking about, is like, how does a given solution go from kind of expert, kind of siloed explorations into something that might scale to a whole staff. And then I think there's a fundamental question that we need to be asking ourselves with regards to all of this stuff, all the data-driven methodologies, all of the kind of work in generative design, digital twins, and that's the topic of reinforcement. Are we engaging in this technology to do something fundamentally new and lead to better decisions, or are we just getting better at doing the wrong things? And this is an existential question, and maybe it's because I'm 39, getting close to 40, that I'm now grappling with these kinds of things. But I think it's so important as we go down this trajectory of rapid change with technology to really be looking at this. And today, as a basis of discussion and provocation, today we have professionals can employ numerous tools to generate thousands of urban development iterations. And one of the things that I kind of find myself concerned with as I go through Twitter posts and LinkedIn posts is that you can find numerous published examples hitting the marketplace from various vendors that seem to be shockingly efficient at creating design variations that share the aesthetic qualities and urban planning attentiveness of the mythic Pruitt-Igoe, which haunts our modernist history. And just yesterday, I saw a post on LinkedIn that was touting an algorithm for parking layout, and the ability to lay out huge swaths of parking, allowing users to control parameters and requirements and verify that their counts are matching the targets for the project. But yet, if we look at the world today, it seems pretty clear that the evidence is pointing to the world that we live in today needs a great many fewer parking lots to support our automobile habits. This idea of data-driven, in our view, goes beyond this idea of reinforcing our kind of habits, reinforcing our professional biases, and making us more efficient at doing the wrong things, but really should be thought of as being something that will position us to do better things, to make the built environment better, to think about ways of delivering work that will, not only reduce waste, but maybe in some areas eliminate waste entirely. That can lead to new modes of performance of architecture and new ways of approaching space making. And so as I kind of transition into the next segment here, which will just be a couple of quick sketches, I'm going to be zeroing in on a particular topic that looks at a rather, I would say, it's a fairly popular concept that's growing, at least growing in popularity in the world of analytics, called business intelligence. And as I go through these, I want to kind of emphasize that it's less about, for us, this idea of kind of using empirical methods to reinforce and test what we know, but maybe it also allows us to flex our creative muscles and provide a critical method for imagining outcomes we would otherwise be unable to synthesize without computational power and data sources that are example. So as a quick rundown of business intelligence, this concept you might have heard, it's sort of a buzzy word. There's a number of tools out in the marketplace associated with it. Really refers to a system for collecting and correlating and reporting data. And I think that's something that where if you look at something like a lot of the work that you just saw, where it's all about generating data, I think the business intelligence is more about, okay, you have a lot of it. How can we get into the nuts and bolts of it and kind of make use of it in some way? Whether it's clean or not is in some ways another question entirely, and very much a part of this conversation too. So couple of things that really interest us about this, we have software solutions that are out there that are designed to connect and consume and correlate data from multiple and often disconnected sources of data. Really looking at that idea that we need to bring a lot of sources of data together. In general, there are solutions that are readily available today to a very large user base. Power BI is very popular, what we're seeing in architectural businesses, in owner-operator construction businesses today. Really a tool that's available to anyone that has the Microsoft Office suite, which really starts to speak to a footprint that has an opportunity to drive some level of impact. It's pretty open-ended in terms of being able to create analytical content. And it's open-ended in the point wherein you don't need to know how to code or be a data analyst at all to really make use of it, which can make the technology both really powerful, but also kind of dangerous. And I think it's always important to look at the dangers of technology along with its positive aspects, certainly. But I think as I go through some examples, this concept really offers for us a practical means for professionals to leverage high volumes of data information and discover outcomes, discover relationships that are important to them and their business, and maybe find outcomes and relationships that they didn't know existed. So what does this actually look like and feel like for a user? This is a set of tools that we built on top of a platform called Microsoft Power BI. And the thing that's kind of attractive to us is this ability for using the data connectors available in the software and through a rather conventional drag and drop methodology of composing, you're able to create these layouts that are interactive and can allow a designer to start to craft a narrative backed up by data or supported with data that can be shareable. And there's an interesting kind of pipeline that exists within this technology wherein, in conjunction with some of the tools and extensions we're making on top of this, allows a modeler with a basic modeling skill set to go from modeling environment to a dashboard to a shareable web report without having to write a single line of code. And that kind of barrier to entry, we think, is going to continue to grow in prominence and importance as we move along here. So a couple of sketches and examples here. This is an interactive report that takes 3D model data from Rhino, composes it into a report that allows a designer and their stakeholders to compare different design options. This is backed up by a tool that we sell called Semantic, which enables users to integrate data on top of their Rhino information and then compose with common tools these kinds of reports that can allow for rapid comparison. And really it gives the professional the ability to tell a story with their data in a way that they couldn't previously, and perhaps also navigate data complexity in a way that they couldn't do before, or find a correlation that they didn't quite realize was there. There's other kind of components that can be woven into this idea of analytical information, environmental analysis being brought together with other sources of information. So you might have an analysis being running by one set of professionals, a design model by another set of professionals. This kind of technology allows you to bring those concepts together into a holistic view that you can have a dialogue about. There's implications for this technology on the ability to coordinate other systems and other data sources relative to building information models and construction data. This is a dashboard report that was composed that harvested information out of a Revit model and used the same report to connect into a timeline database for construction installation, such that you now have this way of slicing and dicing your information to get an understanding of the relationship between the overall design and how it will come together. And it's composed using these general purpose tools. Going beyond this, we can look at things like data centralization and the management of building information models at a portfolio level. This is a video that is not playing, it is now, that's looking at a series of models harvested to a centralized data environment. Data centralization is a very mature IT concept. And what we're aiming to do with this kind of demonstration is say that, hey, your building information models themselves can also become a centralized resource that would allow you to assess things like the quality of your standards applications, the uses of your content across in an architecture firm, your models, or if you're a building owner and you're receiving model deliverables, you can start to leverage these assets in a way that can make sense with your other data and the context that you're working. And then finally, and maybe as a bit of a thread to look at our topic later this afternoon on digital twins, it occurred to us that there is a very interesting intersection between concepts related to data centralization, business intelligence, and the ability to deliver digital twins. This is a prototype that we put together that looks at a small office space environment. We happen to have access to a data set that looked at occupancy records, environmental trends for the office. We had maintenance schedules and things like that for hardware maintenance and IT maintenance. And these are brought together in a single environment. So different data sources coming together to be representative of not only the building information model, but all the sort of a supporting auxiliary information that can paint a picture of the activity of the built product and its behavior over time, and presented in a common reporting environment that many stakeholders can have access to and make decisions on. So finding, again, intersections and correlations that may have been very difficult to get to before, and ideally would lead to this idea that you would be making better decisions as a builder. So just to quickly sum up, I guess the aim of my opening remarks and examples here is to really position data-driven as an idea that can be practically achieved in ways that address the needs of designers and builders, but also we need to be thinking about data-driven as an idea that should ideally lead to betterment of our built environment by offering us new modes of engaging with the complex systems and data impacting design, construction, and operations. No, thank you.
Thanks, Nate. That was amazing. So guys, yeah, please do add any questions into the chat if you have any. Gonna kind of just start going here a little bit, because I think I remember back the first time I saw this technology and all these cool little levers that you can pull and change the shapes of everything. It was kind of mind blowing. And so I kind of just want to reel this in for everybody who's new to this, because I know it can kind of just be unreal the first time you see this. And I think we have to kind of talk about, you know, how does somebody get started with this? Can they just jump right into, you know, one of these apps or Power BI or Grasshopper? You know, how can we ease this transition for them so that they're not so overwhelmed and scared by all these crazy tools?
Maybe I can start. I think first and foremost, you need a reason and in some form of motivation to do it. And I can maybe just speak to some of my experience learning core software that I was talking about. I think the first time I did like a Power BI kind of training session, I forgot how to use the software within a month because I didn't have an immediate application or need to kind of see it being brought forward. So one of the things that we often dialogue about with our clients is identifying where are the sort of the meaningful use cases that can bring about some measure of improvement or transformation to your business. And your inroad to that is going to be a very powerful departure point and a way to sort of galvanize people in your company to kind of pick some of this stuff up and learn about it. You don't want to, in my view, things like training and learning software is less successful if that kind of that value proposition to yourself isn't there. I can, and I'm sure Ian and Julia can share examples of similar examples in their own history. I remember the first time there was a Revit training going on in an architecture firm that I was a part of, and everyone was really excited in the workshop, but their immediate project needs had them continue to crank out documents in AutoCAD and other pressures being put on them, and they had to be retrained later on because of that kind of that lack of connection. So that's maybe one early 30,000 foot departure point for all of this, is to really think about that meaningful use case that can impact you and your company.
I will I don't know if this ties into what Nate is saying, but somebody shared this morning on LinkedIn an image of a Dynamo Graph that somebody had created that's 200 nodes to do some sort of model checking thing. And I see these all the time. Everybody loves to send them to me because I started the Dynamo project a long time ago and I unleashed this kind of on the world. And it's kind of like, ha ha, until it isn't, because that represents a huge liability for our company. So those of you who don't know Dynamo, it's a visual programming language, runs on top of Revit. And we encode a lot of our project-specific automation knowledge and firm knowledge in these tools, whether it's Dynamo on top of Revit, Grasshopper on top of Rhino. And then oftentimes that stuff goes on the server and just like disappears for a project after a project, and then we rebuild it on the next project. So that's one problem, a huge liability. The second problem, though, to your point, though, Brian, is somebody comes into that Dynamo Graph or that Grasshopper script or whatever that automation thing is later on and looks at it and is like, I have no idea what this thing does. I'm going to rebuild it. Or, wow, this is way too hard for me to use. So when we started Hypar, we identified even that level of usability as being way too granular, way too down in the weeds. You know, in HypeR, whereas in Dynamo, you might have to do 200, 300 nodes to generate a structural system. In HypeR, you add one system. It's called the structural system. And then it has a whole lot of settings you can change. You can use timber framing, you can use steel, you can use all different types of connections and stuff, but you basically put in one system. So the idea is that we can increase the number of people across an organization which can access this system. You know, Nate, you had a great graph earlier that was like, you know, managers, operators, experts, wizards. All of our automation tools right now are used by the wizards, except for Revit, you know, which has a slightly broader thing. We need to broaden that across that entire spectrum. And to your point earlier, also about no code, that's what a lot of, when we talk about no code interfaces and other aspects, building websites, business intelligence applications, that kind of stuff. That's what no code is all about. It's about bringing everybody in to play with these tools.
Yeah, I can add one more thing, I think. I would say from my own personal experience, you know, don't start trying to generate an entire building. Start with one piece, and one piece that you know what the outcome is going to look like already. So if you do, so for example, and just in general, when you learn to code, they don't say like, you know, go create some thing that's never been invented before. You start by building a website or doing a really simple database, something that has been done before, that there's lots of resources on, and that you know what it should look like. And I think that's really important, that you're not just sort of like unregulated, just like kind of, you know, throwing stuff against the wall and hoping it sticks, but rather try doing something that is integrated into your practice already, and just trying to either automate it a little bit or make it a little bit easier to do something, just taking a piece that you're already familiar with and updating it, you know, in whatever way you think it can be improved. That's been my experience. It starts small.
That's great. That's kind of how I started. I remember I was trying to convert a detail line into a model line or a symbolic line or something like that. And they're just like, oh, this has got to be Dynamo. I'll just go in here. And of course, I needed to learn how to code to do that. But so a lot of people think that, you know, like a blank canvas is the ideal way to start a new project. And when they hear data, they think, oh, you're just going to create all these restrictions on me, and it's not going to allow me to design and be an artist or a sculptor. What do you guys say to that?
I think there is a conversation that needs to be had among designers and professionals in the space of architecture in terms of where they are placing or misplacing the value of their activities, and where their actual creative insight and input is going to be put to best use. There's something we see quite a bit on the consulting side of things, is a high aversion to standardization in many different respects. As I started to gravitate from my career as an architectural designer into technology, quickly realized that if you're constantly trying to reinvent the wheel on a product or service, at the end of the day, you're giving yourself a time crunch that is going to be far more restrictive to your creativity than a kind of a, you know, working upfront to comply with standards, or find opportunities where, in the case of algorithms and a lot of what Ian was talking about, you know, in the world of software, you are very rarely starting from any form of scratch starting point. No one's opening up Visual Studio and starting their code from nothing. And to be effective and creative software developers, and both a services or a product company, requires us to really take the best of what works and find ways of reapplying it, whether it's in a form of a template or a algorithm, class library, things like that, because those ultimately just become fuel for us to then think about the next problem and think about ways of solving something better in the future. And it enables continuous improvement. And I would argue that continuous improvement and the ability to build on past successes and also evaluate past failures is just as much a creative exercise and important to fuel a creative exercise as does the blank canvas.
I don't have anything like profound to say, but I do think that if you can make something really cool out of a lot of constraints, I think that's far more impressive than just starting from nothing.
I'll share just one anecdote. I was a couple weeks ago at the Industrialized Construction Forum at Stanford, and I saw a great presentation by Jan-Henrik Goldbeck, who's the CEO of Goldbeck Construction from Germany. And Goldbeck Construction, when I talked to my presentation about entities around the world who already have systems that they use and deploy regularly, and they want to encode those things as software, they are a perfect example of that. They're a 60-year-old construction company, and they have systems for offices, schools, and parking garages. And he said, we will build you an office, we will build you a school, or we will build you a parking garage using our systems. And they will be wonderful buildings, and they'll be delivered on time and at the cost that we agreed upon. And they'll be perfect in every way as a building for the thing that you need to do. But if you come to me and ask for a stadium, I won't build it for you because my systems don't build stadiums. This is an emergent way of thinking about buildings as products, as opposed to buildings as projects. That is taking hold, especially in the larger sort of contractors around the world who are realizing the value that they have to offer in their decades and decades of embodied experience in building systems in certain ways is positioning them to deliver value higher up the chain than they have traditionally at the end of the design, bid, build, construction process, right? They're going to owners now, or owners are going directly to them and saying, that system, can you just design a building for this site? Because I've got this hospital I've got to put up, it needs this many patient bedrooms. You know, you're an expert in hospital construction, design that for me. And why this is important to the people who are on this phone call is that it will disintermediate architects. The architects will leave architecture and they'll go to work for those companies, and they'll work on making those systems better and more beautiful. And they'll work on making those systems able to deliver offices that are better workplaces, healthier workplaces. And then those systems will be delivered as products. So HypeR is supporting that vision of the future, because just generally we think that computers don't do enough in architecture right now. You know, the fact that you still open up Revit 20 years after Revit was introduced and you see crosshairs and it's like, good luck building a building, you know, like how many schools have you built before? How many hospitals have you built before? You know, just think of whatever kind of work is inside the firm that you're working at. Like you've done dozens or hundreds or sometimes thousands of those types of projects. Why are you starting from nothing? Computers should do more.
Yeah, I definitely feel that, especially when you reference the hospital, I feel like those projects can get extremely complex, and you're given all this data from the client, and you've got to figure out a way to transition this into a building. But a lot of the times that data is just kind of pushed under the rug and you show this flashy facade instead. But if we can have this design in this building come back with that same data that we were given in the beginning, I think it can really transform some things in the industry.
Yeah, and I give the example of healthcare specifically also because our interactions vis-a-vis healthcare are usually going into large firms who have a specialization there, and they say, let us take you over to our healthcare planner, who is somebody that has 25 years of experience in our office doing this. Now, when they have 35 years of experience, they're going to walk out the door, and you're going to have to go and find somebody else who has that experience. That will go on forever. The other thing that you could consider doing is encoding that experience into systems that can run in an automated way. And that's what I think our industry needs to get good about thinking about and grappling with, is how we're going to make that transition. Because if we don't make that transition, the transition will be made for us.
So does data have a PR issue?
What do you mean by a PR issue? Like, I saw that question before we started this, like you had sent it out. Like, what's your, do you have an example of, I guess, the genesis of that question?
I mean, I think people are scared, you know, that the automation of things takes away from the industry, or that it holds constraints on them, where I feel like the process of computing can really exemplify the industry in a lot.
I think, yeah, perhaps. I mean, there's probably quite a bit more PR issues than even that. You know, when we start thinking about everything that surrounds data security, the opportunity, the data privacy, all sorts of things has bearing, I think, on that question. I think there's just, you know, humanity itself has a natural fear of the unknown, and having now worked in the design and construction industry for quite a while. Again, I'm kind of going back to my existential crisis that maybe I'm experiencing with regards to the uses of data. There's quite a bit of the industry is highly risk adverse. It's very slow to change. People are, you know, I think under increasing pressure under the current paradigm to do the work they need to do. And I think it's incumbent on groups like Hypar and people like Julia and consultants like ourselves to really help frame the opportunity for a business to find a better way of doing things. Because, and I think this was sort of implied in the opening remark, and maybe even just now implied by Ian, either you make the decision to chart your own destiny, or something or someone is going to make the decision for you. And if we think about the digital transformations as made more urgent by COVID-19, imagine what the global pandemic and that crisis has done in order to finally, in many ways, force firms, many of them from our direct experience, kicking and screaming to use more cloud infrastructure, to embrace the idea that there is other ways of working via remote working opportunities. There's been a change in the workplace culture. And this was something that was not decided by these organizations, that they were going to chart their own destiny. Some of them were ahead of it and made that switch really quickly. Many others struggled to find that. So that's kind of the binary. There's like a binary sort of position there that you might want to consider is, are we going to wait for transformation to come to us, or are we going to get out ahead of transformations that are in many respects inevitable?
No, I think that's really great, Nate. And I'm sorry no one else has time to respond to that. We are running out of time, but I wanted to thank each of you, Julia, Ian, Nate. It was a great discussion, great slides. Really appreciated the time with you guys.
Thank you, Brian.
Thank you so much.
Thanks for having us.
Yeah, thank you, Brian and panelists. I thought that was an interesting breakdown of, how to leverage data design and also ways to utilize data for design narratives. Now we're going to move on to the digital portion twin part of our conference. So the definition of digital twins can kind of range wildly from practice to practice and also from profession to profession. And dare I say that some could say that the digital twin term is the new IT term. But these upcoming sessions are served to provide explanations of how architecture practices can utilize and benefit from the use of digital twins. So I'm here to introduce Chikara and Alex. Hi, Chikara, Alex, do you want to turn on your cameras and share your screen?
Hi, Lauren.
Hi, Alex.
Hi, Lauren. Hi, everyone.
Great. So Chikara is the Director of Digital Technology at Keough Architects, and he leads a team of interdisciplinary designers and technologists to drive digital transformation in practice across disciplines. And Alex is a principal at Keough Architects and works on large and complex academic, healthcare, civic, and commercial projects. And Alex leads Keough Architects Building Facades Group and holds a special interest in developing innovative and high-performance exterior envelopes. And together today, they will be presenting Digital Twin in the context of practice. So welcome, and thanks for being here.
Thanks, Lauren.
Thank you, Lauren, and good morning, everyone. It is our great pleasure to be here today. In our session, we're going to introduce digital twin in the context of a collaborative design practice. We have a lot of exciting ideas and stories to share today, so let's get right to it. So, 50 years ago, 200,000 miles away from Earth, 3 astronauts were suddenly disturbed by an explosive sound that shook their tiny spacecraft. Within seconds, the cabin was illuminated with warning lights and cacophony of alarm lights. Alarms began to ring in the ears of astronauts. What they didn't know at the time was that the explosion in the oxygen tank had critically damaged their main engine and left their valuable oxygen supplies leaking into the space. However, they were able to stay connected through the telecommunication, and engineers and scientists on the ground were able to run a series of simulations to come up with a solution that adapted to the change. Utilizing the oxygen in the lunar module, discarding the heavy service module, and eventually brought the 3 astronauts back home safely. This story marks the origin of digital twin, but also highlights the important value of this technology. Digital twin is a digital copy of a remote physical asset that is connected through a continuous stream of data. This data communication is used to update the digital model in response to the change in the real environment. For the Apollo 13, the physical asset was a spacecraft, digital copy was a simulated module in the Kennedy Space Center, and the data stream was provided through telecommunication to keep track of its orbital path, fuel and oxygen level, and any visual and acoustical data transmitted between the two. In the real-world environment, things change constantly, and the digital twin provides means to prepare for uncertainty and enable us to adapt to the changes by running multiple iterations of what-if scenarios to explore optimum solutions. As we continue to challenge in the face of global pandemic and climate change, we believe that this concept of digital twin is extremely powerful and also very relevant to the needs and goals of our design practice.
Thanks, Chikara. I'm still rattled by Ian's comments. I'm a little afraid of what he said about architects. But anyway, just a little bit about Keough first, as an architectural practice especially. So we're based in Southern California, about 165 people now with offices in LA and San Diego. And we have additional employees nationwide nowadays, as I'm sure many other firms do. But that aside, our Keough has a deep-rooted history and reliance on digital technology. The use of technology in our office has to be with meaning and purpose, a little bit to Nathan's point, not just because we can use the tool and just because we know how. We've always been open to a lot of research and development and experimental use of tools, whether they lead to something or not. We were really early adopters of Revit and BIM, and it seems like BIM is, digital twin is the new BIM. And but we also use many different platforms through design, documentation, and construction, and have gone through kind of concept through fabrication ideas. Thus, having a in-house digital technology team that includes Chikara as a director and digital experience designers. We now are expanding into more simulation work, client-facing tool development, but also continued use of VR, AR, MR. And we also now have sort of a data and knowledge manager in-house to expand access and visualization of data, as was described previously. But the purpose has to be to make sort of work more functional, to be flexible, but also engaging and continue to innovate and work in a more informed and efficient way. So our clients are generally focused on mission-driven institutional clients, really layered sort of leaderships. We work a lot in healthcare, higher ed, K through 12, science and technology, but also medical education like this building. And this building really started our journey of this chapter in the digital twin exploration that we're going to talk about today. This is a health sciences building that combines programs for 4 schools, has student spaces, simulation spaces, flexible labs. It's built for the future, built for flexibility with long span structure and additional capability in shafts, et cetera. Heavy use of BIM, Revit, and performance-driven parametrics for facade development, Navis for construction. So kind of the traditional, what I call digital twin up to now, that is the project knowledge repository and sort of, has a history of the evolution of the design. Now testing that flexibility though, was the client coming back to us and saying, well, there's a space in this building that's tucked away in the back that was going to be a bookstore. We now want to make that a food services restaurant, basically. That's quite a change in function, not what the building was designed for initially. So in order to get sort of a sense of the as-built condition and expand the traditional digital twin, Shakar and I rented a Matterport camera and started to scan the space and basically scan the as-built condition from a photographic perspective, but also getting this point cloud information, which here you can see we kind of built the slider that goes from point cloud to what the initial bookstore was to sort of see the difference. So the other thing we did was scan spaces above and below. Infrastructure of putting food in has an incredible, impact on infrastructure. So you're going to have hood exhaust as well as grease interceptors and traps kind of coming out. So we scanned kind of in a traditional sense what was below, above, and around all of this space, which also facilitated obviously the work of our engineers who were located in different places. And during COVID, access to facilities and travel was obviously difficult. So this provides a great sort of visual record of what's there so that you can always go back to it and access it at any time. Now, as we stepped out of the space, though, Shakar and I started talking. We're like, well, this is kind of interesting. As architects, we're still very limited to sort of static photography, maybe some video, maybe some zoomy drone shots. And we took our camera out into more of the sort of engaging space. And I was like, well, this is also an opportunity for people maybe to engage with the architecture in a different way. Photos, videos you're still an observer. You're not able to create your own sort of exploration and experience. This tool actually allows you to move around, pan around, and kind of gets you into the space and maybe as an opportunity to engage with an audience anywhere in the world in a more engaging way and share our design and the architecture in a better way. So that was that. Fast forward a few months and Keough during the pandemic decided also to move offices, making our life even more difficult. So we were fortunate enough during COVID to experience incredible growth. And so we had outgrown our old office space, our lease was up. So we found new space not far from where we are now, just 10 blocks west on Wilshire. And as we were walking through the space, Shakar and I, and this is Shervin here, are one of our digital experience designers, a few ideas arose. One, could we use this process of recording, the shell space? This is the empty shell, and then we were going to design it and we're going to build it out and sort of use, again, our scanning process and our photographic record process to sort of build a record, build a history of how our project evolves. We were now our own client. This was an opportunity. We wanted to experiment with new tools. And so we busted out the Matterport, took 360 shots, scanned with various apps for, using LiDAR technology, et cetera, and just kind of played around. And the idea here being that we wanted to use our office in construction, but also beyond as a sandbox. The other was really to use, the forced and accelerated need for remote work as a method and opportunity for the future of our practice, to bring our people together wherever they're located, at home or in different offices. And how could we use technology to enhance the sort of physical co-office we were building with a digital and virtual co that would allow us to connect all of our staff, whether at home, whether in a different office. And, this was really a way, or we're looking at this as a way to share our values, to boost engagement, continue to connect our staff, and really to kind of continue to evolve our culture as an architectural practice. And at the same time, how could we maybe share who we are in a more engaging way as a practice with clients, a broader audience, students, future employees around the world? So how could we make a physical and a digital co that really help and inform one another as we evolve as a practice? And so Shikara will talk about a few of the things that we developed for that.
So at our research group, we started exploring various solutions for digital twin. And our goal is, as Alex mentioned, a digital twin not just for our new buildings, but to twin our creative and collaborative design practice itself. In other words, it is about our people, our projects, and our activities in relationship to the built environment that we are aiming to capture and to learn from. So we began developing our digital twin platform in a game engine environment that can host multiple concurrent users and multiple streams of data. For us, the digital twin is a sandbox of curiosity. And the next several slides will introduce some of the key features we're currently developing at Keough. The first example here demonstrates this idea of time machine. As we began the construction of our new office, we started scanning the space. To create the basic skeletal framework for our digital twin, and then we realized that we often don't get to see what's behind the finished walls and floors, things that are actually enabling our home and our offices. So we decided to overlay a series of 3D scans at a different phase of construction on top of our design model, so that we can always travel back in time to reveal what's behind our walls, as much as to show the builders and contractors the assembly model of what the space is going to look like in the future. And then the next demo is about our people. As we are moving to the new office literally next month, it's a new space for everyone, and we also have a lot of new people joined us over the past year. So we thought it would be a great platform to connect to our employee database and to create an interactive seating chart for our new office to help all of us acclimate to the new environment. We also embedded a searchable directory to the platform so that even our visitors can easily find the people they're looking for. We also have a lot of activity space in our new office for things like group meetings, individual focus rooms, and wellness rooms. So we decided to install a self-check-in display at each and every room to optimize our spatial usage. And then we connected our digital twin platform with a database to display the real-time activities across our space. This allows us to share what rooms are available now and also in the future, but also it allows us to build a spatial database to run various analytics, such as which rooms are underutilized, which rooms are more popular than others. We are also planning to install various IoT sensors in a space to evaluate the local temperature, illumination, acoustics, and combine these metrics of spatial data so that we can begin to understand the human comfort and our relationship with our own space. We are also connecting our digital twin with the local weather station data. The example here simply displays the raw data as a backdrop at our quote-unquote virtual reception desk, but also linking to the virtual environment to provide a visual cue to the users. From here, our next step is to connect to our building's energy usage data to spatialize our activities and preferences with respect to the changes in the environment. The last example here that we'd like to share today is our Project Explorer. Much like room usages or energy usage, we live and breathe with creative ideas for our projects. And as such, project data is perhaps one of the most important and intriguing live data we wanted to capture. So we decided to connect our digital twin platform with our active project directory and put in various 2D and 3D assets so that people can join together in this virtual space to interact and exchange ideas, as well as to conduct the virtual work together in the space to share the experience. We are still in early phase of our research, but we are very excited to continue our exploration, and we hope to share more updates in the near future.
Especially once we finally move into our space. So, I mean, in terms of a firm, it takes a whole group, it takes a village. I mean, you see Shakara and I here today, but this is really a commitment as a firm, as a practice, as a culture, to be okay with research and development, to launch into things where you don't know where it's going to go, and to invest in that. And with our partners here and Shakara's team, there are multiple people at Keough that are invested in this, from the leadership across the board. And this is really, I mean, it is both a time and a financial investment, but we think it's worth it. We think it's an integral part of our culture, and we think it's an important part of preparing us for wherever we go next. Thank you.
Thank you, everyone.
Thank you, Alex, and thank you, Chikara. I know that I am happy to start working in our new office and environment very shortly. So up next, we have, we're going to continue our discussion on digital twins, and we're going to go into a panel discussion with Herman Aparicio, who is a co-founder at 060 Accelerator Program and a project manager at Trimble Consulting, which provides strategic advisory and advanced project delivery services to companies worldwide. He has over 10 years of experience in both research and professional experience in AECO industry, delivering large-scale building and infrastructure projects. So welcome, Ron.
Thank you, Lauren. I just wanted to confirm that we had all speakers on the call. We have Azam, Tony, Daniel, Miriam, and Emmanuel.
Yeah, hi, Herman.
Hi, Herman.
Hi, everyone. Good morning. All right.
Hello, Herman.
Let's go ahead and jump right into it then. Yeah. I'm very excited about today's topic, so I wanted to introduce and mention the names. We have Azam Khan joining us from Trax, Tony Gill with IBI. We have Emmanuel Daniel with Microsoft, Miriam Rusam also from Microsoft, and Dan Isaacs joining us from Digital Twin Consortium. So thank you, Lauren, for the introduction, and thank you to all the participants for participating in this conference today. I'm very excited to talk to you about digital twins and to speak to each of you about this topic. We've seen a lot of interest in this topic through our consulting practice at Trimble Consulting, working with various clients, including government agencies and private organizations. And I think a lot of this interest has come because a number of these organizations have invested tons of money into the facilities, right, into the design and construction of their facilities. And at the end of the day, they're kind of handed over a 3-ring binder with of their deliverables, right? And so it really is a need, right? As I like the way that Ian phrased some of these things in his talk about encoding new learnings, right, into the buildings that we have for future performance, designing buildings that work like a network or web, creating services for buildings that work like APIs do today. And I think he mentioned tools that get smarter over time. I would replace tools with buildings that get smarter over time. And I think we realized this as part of our consultancy at Trimble Consulting. And so in 2018, we launched an accelerator program called 060 to work with startup companies to help deal with some of these challenges. So With that said, I have three main goals for this discussion. The first is to define what digital twins are. Right, I think we've heard the term now a number of times during the conference, but maybe we can just baseline what digital twins is for each of the speakers on this panel. Maybe explain what are some of the opportunities and challenges in having a digital representation of a physical asset for both owners and other stakeholders. And lastly, how can we illustrate, right, how the design community could participate in developing digital twins while providing clients with additional value to build a better future for all. So with that, let's start with the first question. Maybe we can start with you, Azam. I see you on the call here. Can you define what digital twins is to Trax, and maybe talk a little bit about Trax itself?
Sure, thanks, Herman. The aspect of digital twins, I would say, contrasting to the previous parts of the day, is that and similar to what Shakar was saying about the use of a digital twin, we at Trax we sort of view it as a post process. So how to have continuous improvement after the building is built. Of course, it would be great to consider these things during the design process, and that would be ideal. And in this way, sort of NASA also does that. As part of the Digital Twin Consortium, I'll leave the formal definition to Dan, but we, just because of our computer science background, I've always thought of the digital twin as kind of a debugger. So how do I, understand how the building works? What features would a debugger need to have for debugging a building to make it better over time, and really ultimately support continuous improvement? And so at Trax, we really think of three aspects of the digital twin: the physical asset and how we can understand how it's performing at all levels for a building or a campus or a city, the standards that we encode to measure the performance of that asset, and the third part is encoding best practices as processes, as process maps, and linking those to the standards and the assets, so that we can actually continuously check the compliance towards a lot of these standards. I think it was maybe Nate that said there's an aversion to standardization and an aversion to standards in general. But I think it's unfortunately, buildings are the #1 cause of greenhouse gases. We have to think of almost everything we've done in the past as an industry as kind of an anti-pattern. And how can we, stop doing those things and do things differently?
Great, thank you. So maybe we can jump to Dan next. Dan, can you help us define what digital twins means to the Digital Twin Consortium? I think you're on mute, Dan.
Yes, I am. Sorry about that. All right, great. Yes, in fact, one of the slides I had sent you will actually is good as a background to share. You could share the screen on that, or I can. Great. So this was actually just a little bit of an introduction for those of you that are not familiar with the Digital Twin Consortium, and looking at it from a mission and a vision statement, really looking at driving the awareness and the adoption of digital twin. Let's go forward one more. Keep going. There we go. Thank you. One of the first things we did within the consortium was to make sure that we were all speaking the same language, had a common understanding. And the approach, after several months of going through and actually surveying what had been already out there in terms of a definition and looking at it, you asked 10 different companies, what is your definition of a digital twin? You'll get 10 different answers. In fact, we found you'll get 15 different answers, because even within the companies, there's a concept in terms of, well, what the digital twin means to me. So what we did was we really went back to the core fundamental foundation elements. The foundational aspects of this is where a digital twin is a virtual representation of a real world entity and or process, synchronized, which is very key, at a specified frequency and fidelity. And we had several questions say, well, what's the difference between a BIM and a digital twin? And the simplest answer is really a digital twin brings a BIM to life. And if you look at it, we had a representation here. This is a wind farm itself. You can see the physical farm, and then you can see the virtual representation. But you can also see that level of synchronization that's necessary, that data that is being fed back from the physical to the virtual to ensure the fidelity or the requisite level of accuracy of precision is there. And that's at a given frequency as well, which has been labeled the twinning rate, right? So you have the virtual representation of the real entity and process synchronized at that specified frequency, that twinning rate, to give you that requisite level of accuracy. And then these other elements actually are here just to show you some of the aspects associated with that. And there's an example of that, and that's really an answer for one of the other questions, Hermaine. So it's really, next slide. So that's the what. But now we look at it in terms of the definition, the three pillars supporting that is really the digital twin systems transform the business by accelerating, and this is key, the holistic understanding, or being able to achieve the highest confidence level of making your decision and being able to be most effective in that action and decision. And another key point is, and this in terms of, from our infrastructure working group, looking at both brownfield as well as greenfield opportunities. Digital twins use real-time and historical data to represent the past and present, but also to simulate and predict the future. And if you think about that, the way the chair of our steering committee states this, and this is Bill Rue. Bill Rue is the CEO for digital transformation at Lendlease. And he says, what this really does is a digital twin gives you a crystal ball. It allows you to look at the historical data, to consider the situational awareness, the event intelligence happening now, to be able to simulate and predict the future. And so these are, along with the motivated by the outcomes in the use cases, this really gives you that foundational element between the what is a digital twin and then the key pillars in terms of supporting that definition.
That's great. Thank you, Dan. I think the pointing out, the BIM isn't enough, right? It's all the other data that comes along with the BIM that is needed to create that digital twin. And for that, we need platforms to be able to achieve this vision, simulate and predict that future that you mentioned. So with that, maybe we can jump to Emmanuel and Miriam from Microsoft. Maybe you can help us define what digital twin is and what it means to your organization.
Sure. Probably I'll kick it off, then I'll hand it to Miriam. Good morning, everyone. My name is Emmanuel Daniel. I'm part of Microsoft Global Workspace Services. And what I do is I take care of all of the core real estate assets Microsoft owns and operates. We are responsible for around 800 locations across the globe. And what we try to do is we try to make experiences. So anyone that touches and comes into contact with our buildings are able to have a delightful experience. With that, digital twins for us is actually extremely important, because what it does do, it allows us insights and intelligence on two fronts. Spatially, where we try to understand as asset owners, as real estate owners, how is that space performing? How effective is that space? And what are the benefits I can get from that space? And visually, in terms of understanding human behavior, the behavior of the elements, the noise, the sound, the light, the airflows within that space, and how we can use all these elements together to be able to influence and boost productivity of the individuals operating on that space. So for us, digital twins is a spatial twin and a virtual, very similar to what Dan was describing. I'm talking to you from the aspect of owners of real estate as to why that is important for us. So for us, we take the spatial model to try to make space effective. And we take visual model to be able to understand the correlation between the environment and human behaviors to drive higher levels of productivity. Miriam?
Yeah, thanks, Emmanuel. Hi, everyone. I'm Miriam. I work with Emmanuel at Microsoft, and I'm in the Azure or Internet of Things engineering group. So our team is providing platforms and capability for IoT and digital twins and other innovations as well. So yeah, I think from a definition perspective, totally obviously aligned with how Emmanuel described it, right? How ultimately a customer at the end is using the digital twins to be able to drive the business decisions. Totally aligned with the definition Dan provided. In fact, we work closely with Digital Twin Consortium. We're one of the members and co-founders of Digital Twin Consortium. And I think from a platform capability perspective, maybe I'll add a little more from that perspective. 2 years ago, because we saw digital twins as an important concept to the market, obviously it's been existing forever, right, in various forms across various industry, whether those were BIM models or 2D, 3D models of every other environment. So we really saw, especially as we sit in the IoT business and providing IoT capability, the transformation we saw and the need that we saw in the market is, yes, having this platform that allows customers to build this digital representation of their physical environment, whether those are buildings, railways, factories, other infrastructure, could be cities, but also allow this integration, rich integration with a variety of data sources, obviously. But where we saw that becoming transformational is this integration with IoT data. Obviously, the physical environment in the past 10 years or more, it's been proliferating with all these IoT devices that are trying to capture the state of what the environment is or what the experiences is. And so being able to overlay this data and bring to life any of this representation that exists of the physical world actually becomes a game changer in the way customers and can actually drive new experiences. And obviously we with Azure Digital Twin platform, that's what our customers can do, obviously, and then importantly, I think, align with the definition of digital twins. Now that you have this digital replica where IoT data is actually bringing it to life, then you can keep doing any sorts of simulation or intelligence, or looking really at the history of what your physical environment is using this digital canvas.
Thank you, Miriam. And maybe lastly, we can go to Tony. Can you help us define what digital twin means to IBI Group?
Sure. I think one of the things that I've been doing, working on very complex facilities for 25 years, all different types of institutional facilities that run 24/7 operations, and they go through a whole bunch of evolutions. And I always call those buildings, they're live buildings, meaning that they're not static, they're always changing, they're always adapting, they're always going through something. And so at IBI, one of the things that they came to me and said, Tony, look, we need to talk about digital twinning. And I started to look at what it is and what does it mean to us as an organization. But then I thought about what does it mean to me as an architect. And I realized that actually as architects, we've been doing digital twins for a long time. It used to be on paper, it used to be in models, and it's evolved into technology. So the digital twin for me, it's been in our DNA for some time. The only thing that's come differently with technology now is we can visualize it differently, and we can now layer in the operational piece. So for us, the digital twin is a representation of reality in its physical and operational state, working symbiotically, meaning it's all coming together as one piece. So I think that's a big difference, and where we're heading with the digital twin, the connection between the physically built and the digital design environment, which informs each other through IoT sensors and all these cloud-based things that just gives us more information about that particular digital twin. As an IBI group, we have well over 200 software. We have a software development team, and our software development team is working with us on how we continue to evolve our work and this whole digital twin process. And then the other thing we realized that the digital twin is not just a BIM model, but the digital twin, with working with our software engineers and some of our data collectors, the digital twin is also the the PDFs, the Excel files, the Power BI files, those all are part of our digital twin, and they are digital twin information as well. So it's not just the model and the visual model, but it's all those other things as well that add to that digital twin.
So, thank you, Tony.
Yeah.
So maybe next we can move on to my second question, was maybe to explain what opportunities and challenges lie in having a digital representation of physical asset for both owners and stakeholders. You know, we talked about in the last question here what digital twins meant to each of the organizations, and coming to the conclusion that it's not just about BIM, right? There are other data sources that play a role and need to come together. Miriam, you mentioned IoT as sort of one of the many data sources in creating a digital twin. Can you talk a little bit about maybe the opportunities and challenges in having a digital representation of a physical asset for both owners and stakeholders that include IoT data?
Yeah, I think as you know, everyone actually hinted on it. One of the underpinning, important things for digital twin is having this representation, right? A common representation or a standard representation, however we want to call it, that helps that everyone understand, a building is a building and it's defined in a certain way, right? So there's a specific language around it that everyone can understand and the machines can understand it, right? So I think one of the biggest challenge and across the board, and we see it across various industries as well, not just on buildings, is this challenge of having common representations of this environment, whether those are buildings, maybe in the case of buildings, there are more advanced standards in various forms rather than, for example, if we look at different other sectors. And so that's where if we don't have this common representation, right, like anyone can create a piece of the environment, but those environments won't be able to understand each other, right? And so you won't be able at that point to reason consistently about this environment, let alone integrate also other data sources to make it more usable. So yeah, one of the challenges that we see, and also the opportunity, and what the Digital Twin Consortium is also heavily working on, is really on having this standards around how do you define this environment, right? What are the standards? We often maybe hear BIM or other things there. Especially in buildings, I hear various sorts of representation, and maybe all of those are also representing a certain aspect of the environment, or maybe they're focused on assets and not the spatial representation. So there's a lot of work where the ecosystem and the industry need to come together to actually standardize on those, right, for the great good. So that's a challenge both from the implementation perspective, but also from the owner's perspective, right? If you don't have this common representation, you can have a variety of IoT devices and not, you won't be able to bring them consistently. So one of the things that we're making sure from also Microsoft is, one, we're working very closely with Digital Twin Consortium, so we can come at an ecosystem level, at an industry level, what are this type of standards, but more so also for the Digital Twin, Azure Digital Twin platform, the modeling aspect actually is based on a Digital Twin definition language, DTDL, which we made it open source to begin with, to make sure that we're leaning into a world where it was open modeling and open source. We've also started some efforts, and we're working on those also with the DTC consortium, where for different industries, for example, for the built toward smart buildings or the energy grid or smart cities, at least we started working with various groups across the world that are leaning forward in making standards, so that we don't invent our own standards, and see what's out there and can we adapt these things in this DTDL definition language, so then any customer and partner that's building their solution using this Microsoft capability, they actually can base it based on existing standards. So I think that's one of the biggest challenge and opportunity that we see where the industry could ecosystem can just come together and collaborate on, having standard definition for how you define environments.
Agreed. Yeah, that's really great. Thank you, Miriam. Maybe I can ask Azam the same question. Explain maybe some opportunities and challenges, Miriam, in having a digital representation, right, of a physical asset. Miriam mentioned the role of standards that play in creating that vision of a digital twin. Can you talk a little bit about what roles, I guess, standards play in Track's solution and opportunities and challenges in having that digital representation of that physical asset?
Yeah, sure, definitely. As Miriam mentioned, we need to, as Ian sort of mentioned with hypars, have a more standardized set of semantics so that we know what we're talking about and how what things may be the same in different environments. So that's an important layer that's traditionally been missing. Mapping that also into the building automation system is a critical part because we use IoT devices as kind of our own experimental setup, but really we'd like ideally the bulk of the information to come from the infrastructure that's already in the building automation system. And unfortunately, a lot of those things in the past have been very proprietary, but we really need to move towards requiring these things to be more open and more accessible to the digital ecosystem to make them effective. To get there, I think one of the key challenges is really the owner. The owner has to understand that it's their project, it's their job. They can ask for these things, and they have to ask them for them in contractually in a certain ways to make sure that they actually get the data they need. Otherwise, it leads to a significant bottleneck and problem that just is very difficult to work around. Installing your own IoT devices, duplicating the system or whatever it is. That's a key challenge. And then I would say the other, in terms of standards, is standards for evaluation. So the standards in terms of understanding the representation, but then how do we evaluate the effectiveness of this? So there's standards like the smart building standards from ISO, or smart city standards, resilient cities, sustainable buildings, LEED, WELL for human wellness in buildings. So at Trax, we're really interested in coding a set of requirements right from the building codes up to voluntary standards like LEED and WELL, and more broad sort of campus or city level standards for evaluating the effectiveness of your portfolio. And that's really we think the key metrics that should drive what a recommender system would suggest are the most effective improvements to reach those goals. And I'll just add that I think Julia said this morning, doing a good job as a designer, given millions of constraints, that's a challenge, but that's something that we need to, as an industry, figure out.
Thank you, Zom. I like this point about the onerous, kind of falling on owners historically, right? Architects haven't delivered on some of the promises of these technologies because owners aren't requiring them. I think we're seeing more and more of that today, and need some assistance in building that into their contractual requirements. Maybe we can jump to Dan next, and you can talk a little bit about the work that you do with various groups as part of the Digital Twin Consortium, and how you help educate owners and other stakeholders in digital twins, and maybe some resources that are available to them.
Sure. I think that one of the other areas that I'd like to touch on is the fact that if you think about scaling a digital twin from a smart building to a smart city, and then even to a smart country, interoperability becomes one of the key areas that you need to take under consideration. If you think about it, with the very discrete element of a digital twin, and then you create these composites, and then these composites become system of systems. So you have composites of composites. Is how do you ensure that data, how do you ensure the information you need to have is able to have that path through that? So the interoperability becomes very, very key. That is one of the big issues and one of the areas that we are focusing within the Digital Twin Consortium on. And we'll actually have a couple of white papers coming out. We've already had one around interoperability. We'll have another one that we're working with some of the other, our sister consortium to address, from the IoT side of things, our industry IoT consortium, looking at that from a system of systems and understand that. Another thing I think is relative to scale and how do you bring this forward? You need to have model-based capability here. You can have one model, but you can have thousands of instances out there. And so understanding that and how that can be represented in defining that digital twin is another key aspect that looking, in terms of sharing and educating, both within the working groups and outside of the working groups is another fundamental. With that, you want to share your screen, you can go.
Sure.
I think the next slide actually shows the structure of the Digital Twin Consortium, for those of you interested in how we go about that. Right there, the circular one. One more up. There you go. Oops, perfect. So the consortium is truly member driven, and the chairs and the leads, they're approved by the steering committee, but it really is coming from the members. And we started with just about 2 years ago, actually. May will be our 2-year anniversary, hard to believe. We started with 4 working groups and we had 4 steering committee members. We've now grown that to 9, and we now have 9 different working groups. And these working groups all came from the requests of members saying, look, this is great, but we have a lot of expertise. We want to look forward and we want to move forward from these different areas. So you can see how really in the beginning we had what we called our technology, terminology, and taxonomy working group. And you can see that radiating out into all the different working groups. And this is really looking at it from the common characteristics and what are those fundamentals relative to each of the different working groups from a digital twin perspective. And think about that in terms of security. Think about that in terms of trustworthiness, reliability, resiliency. You get into the privacy of the data, especially concerning from a healthcare perspective, but of course with GDPR now prevalent over in Europe and everywhere throughout now, and the privacy of that data. How do you protect that? So looking at these different areas from a common point of view relative to what are the differentiating aspects associated with each of the different domains or vertical working groups that we have here. And then how do we bring that forward from understanding consistently? We, just like with the definition, we've all now through this horizontal working group, we call it the 3T, through that working group, defining what does a platform stack look like? What does it look like when you converge your information technology with the operational side? So the convergence of the ITOT brings forward all the rest of the layers now that you have to look at, which includes the virtualization, it includes the microservices, it includes the applications. So you have this complete stack up. And then how do you interface that with real world data and be able to bring that forward? That's another white paper that we're working on, the team is working on. And interestingly, the technology, terminology, taxonomy working group is actually formed from members of all the other working groups. So we have the input, back to your question about how do you educate and collaborate here. We have input from all the different working groups represented through here. So you can see collaboration not only within a working group, but you can see it between the different working groups. And one example there would be, say, in fintech, if we're looking at operational resiliency. We have a major banking association that's part of the consortium, it's HSBC, and they're looking at different aspects. Well, if there's some security aspects that come out of that that could be shared, say, across the healthcare and life science or in the mobility and transportation, that's easily accomplished through this type of a structure. So that's what I mean, where it's really highly collaborative. The thought leadership and innovation that comes out is just incredible. And everybody's learning from this and being able to leverage that and understand the impact of that. And then being able, that side of the demonstrative is really to create this and actually go from a conceptual to an actual implementation. And so with that, we just announced we had our big information day yesterday. We had over 1,000 people register for that. And I think that's a testimony to the fact that there is so much interest and recognition that a digital twin is critical, really, to digital transformation. It is a key enabler. And it's hard to see how you can say your company has transformed digitally without having a digital twin being in use. So moving forward, being able to demonstrate those lessons learned. So going from that conceptual to actual implementation, every one of these working groups has a series of different use cases, which are turning into case studies that will then translate into lessons learned and being able to share that with the public in terms of and communities of like interest. Also, in terms of addressing your question about education, we have also launched a open source collaboration community as well. And that open source collaboration community now allows other folks to be able to, interested companies or people that have open source projects, to now contribute those. And we use the standard GitHub tooling. And we have, I think to date, we have 12 different open source projects already on our public site. We have several others that are in evaluation by our technical advisory committee, which is looking to ensure that we have alignment with the true intent for open source. Go to the next slide. And one of the things that we've talked about is being able to understand how you would really look at the definition of a digital twin and the requirements from not a implementation specific, but more of a capability focus. And this is another work product that's coming out of the consortium. It was incubated within one of the working groups and then being brought up into the horizontal. So the other working groups now can take a look at this, understand this, and we drink our own Kool-Aid, so to speak. So we validate these, the work product coming out, we leverage those across the different activities that we have and initiatives. And in this case, this is a way to think about it in a non-architectural specific or a technology agnostic and architectural agnostic approach to defining those requirements. And this actually came out of a discussion that one of the members had with one of their customers. As a very multidisciplinary company, lots of different areas and ideas around it. But once they were looking at this from a capability perspective, and if you go to the next slide, the idea and the concept behind this is look at it from what job are you hiring the digital twin for? What do you need that digital twin to accomplish? And then based on that, what are the capabilities? And so to accomplish that, so you're not looking at it from an implementation specific, so you don't have those blinders on. And what this one company found was when they looked at this perspective, it actually identified areas of significance that they hadn't really considered. For example, you can't retrofit security into your design. You need to think about that from day one. So this concept of this periodic table, categorizing it in these 6 different areas, and these color codings are actually aligned to the reference architecture that we have that will be coming out in our white paper. You'll be able to see this, but if you go to one of the items there, say data contextualization over to the far left, number 4 on the far left, and click on the plus sign. Now you get a further level of information. It actually is telling you what does this capability do, and then what does it really mean? And so you can look at this structure and understand from that perspective. So you're asking, how do we share some of the knowledge within the consortium? And outside, we're actually going to be pushing this into our open source collaboration community as we finish this all up. So I just wanted to share some of that with you and give you some of those ideas.
Yes, thank you for that. I like that, going from conceptual to implementation and starting with this question is, what is the digital twin even for? It looks like we're running out of time, but I wanted to get to my last question. Maybe we can go to Tony, then Emmanuel before closing up. How does the design community get involved? How could they participate in developing digital twins while providing clients with additional value? Maybe Tony, you can talk about IBI's experience in providing clients with value, and Emmanuel can talk a little bit about how Microsoft uses their technologies on their own campus.
Sure. I'm going to see if I can share my screen. Is that okay? I'm going to try to do that right now because I have a little. Can you see that screen? I'm trying to get the PowerPoint to come up. Let's put it in PowerPoint mode. Can you, oh, okay. Can you see that?
No, not yet.
Oh.
Not sure. There we go.
There. So one of the things is with the digital twin that I wanted to kind of share, especially for the architects. You know, we know that technology, and you get a lot of these gaming industry technologies that are coming in and starting to take on a lot of the digital twin. So what does it mean to us as architects and engineers? So I wanted to just take a step back and look at what the digital twin is doing. And this graphic here, which was a research that was done by another organization, but you can see here that the 3D BIM model, where architects are really at the front end and they're creating this BIM model. Then eventually it goes into this 4D where during construction it's being used, and it goes up into 5D, and eventually it gets into simulations and stuff, which are, you know, some people are calling 6D and 7D. So there's this constant growing of this digital twin that happens through the process. And if I go to my next slide, if it lets me. So this is just something that I had put together, especially for our internal architects. So, you know, we have over 1,200 some architects just within our organization, and trying to get them to understand what the digital twin means for us as an organization, and how do we continue along the spectrum. So here at the very beginning, you can see there's a planning stage in most projects, whether it's a new build or a retrofit, it doesn't matter. There's always this planning pre-design phase. And that pre-design phase is a lot of data analysis, data collection, and looking at what the owner's needs are and understanding even site constraints. So there's a lot of data that happens before we even begin to design, and including what its functionality needs to be. So if you get into this design piece where the consultants and architects generally spend a lot of the time, they're developing these BIM models somewhere in between the 200 to 300, maybe even 350 LODs during the design phase. But as it moves along into construction, commissioning, and occupancy, the model just continuously gets larger and bigger and more robust and complex. And I'm going to talk about that in a second. But this line along this path of a project is where the architects can continue through, because they are the creators of the initial digital twin, and the digital twin then gets developed further as it moves along. But the architects can continue to help manage that and as it goes through its process. What's interesting about this is that when you get to the end of occupancy and you've got an asset management, this cycle now can just continue, and it can continue with that same digital twin, whether it's through planning or through maintenance. Once you've created it, it's just there, and it's continuously evolving over the life of that building. The thing that I see out there, and I'm just kind of going back a little bit, but the opportunities for us is, you know, there's data collection, there's the visualization, there's the ability to measure building performance and maximizing the utilization and efficiency levels of all different parts of the building. But creating a holistic digital twin ecosystem is really important. And for clients that have multiple buildings, to be able to take multiple digital twinnings and do comparison is ideal for them. So even as architects, when we're designing a school, and this particular school board or group has maybe 20 schools, we can begin to do comparisons of those different schools or different hospitals that one healthcare organization may own. And that multiple digital twinning is a great opportunity for us. The challenge is, though, is managing the digital twin. Right now, a lot of this is over the cloud, and the cloud isn't robust enough to pick it all up. So we do know that there are some challenges there. And you know, as technologies advances, I'm sure that this will eventually become something of less of a problem and issue. So we at IBI, we're creating software to help us get through that. Creation of digital twin is complex, modeling consistency and quality. So as architects, we're their beginners, and we start to build that model and we start to create it. So being able to make that consistent, so we can set the standards and start to set the direction for that model as it moves forward. I think one of the lack of standardization between digital twinning software is really important. There's a lot of digital twinning software out there, and everyone's competing for their share of the market. Until that becomes an open source, and I think the digital consortium conversation is a good one, because that's working towards bringing that as a one solution and creating that open source venue. Just this last slide here, again, back to the architects and where we can get involved. I think of it as three pieces. There's the data creators, there's those that do simulators, and then there's those that do visualization. And I think in the consulting world, we can touch upon all three of those, and we can be in those categories and supporting our clients. The big thing is the clients are challenged by a lot of this technology. So as the architects, we can help them through that technology and help them better understand the life and the cycle of their building and what its performance levels are. So I think we can become part of the ecosystem for that digital twin in the long run. So that's a lot. I've just tried to go race through it for you.
That's great. Thank you. Yeah, I appreciate the framework that I think you use at IBI in developing digital twins for new buildings. I know in the last presentation, we talked about digital twins maybe for existing buildings. Maybe we can jump over to Emmanuel and Miriam and talk about how Microsoft uses their platform for their own campus and maybe some opportunities, right, for the design community to get involved.
Sure. Let me, so for context, the East Campus Modernization Program is transformation of 72 acres where we flattened it out, completely brand new rebuild, and I lead up the digital transformation of that program. One of the most underpinning importance of having a successful digital twin is going to be the quality of data that you're going to get. We talked about building operation systems, we talked about building automation systems, and we talked about IoT devices and sensors. The underlying success of a digital twin, bottom line, is the quality of data that you're going to have in these buildings. And to ensure the data is structured and properly flowing through the multiple systems that you have through the various hops that it goes through, it is critical for us to ensure standards are followed in terms of naming conventions. If you look at our East Campus Modernization Program, on top of the existing building management systems and core building operation systems that are there, we are having close to 120,000 IoT devices that is going into those buildings. So you take a conventional building with 5,000 to 10,000 data points, and on top of that, you're going to add 120,000 IoT devices. You can look at the volume of data that these buildings are going to generate. There is never a problem or shortage of data with buildings. Buildings have always been producing data. The challenge has always been, how do you use that data in a structured format to drive intelligent decision making as an outcome of it? And those decisions can have direct impact on human performance, which is what human behaviors and how they correspond to space is all about. And they can also have direct importance to building performance, because I think the earlier comment, Azam, that you're making is buildings are the largest contributors to greenhouse gases, period. You know, it's a fact. So the goal is not making only aesthetically beautiful buildings, but the goal is making efficient and effective buildings for the occupants and tenants that use them. And that's where the power of the platform starts to come in. What we have decided within Microsoft GWS is we said, hey, you have so many data points, you have so many systems that go into building. One building at Microsoft today that we are transforming has a minimum of 20 systems that go into it, 20 disparate heterogeneous systems that are coming in. Now, from these systems, our goal is, as asset owners, because we own the real estate, our focus was, okay, one, how do I make that space effective? So that directly will correlate to building performance. Two is, how do I make people in that space happy, you know, especially with the whole hybrid work and the return to work scene. Our goal has been, I want to go into office because the collaboration space that I have is awesome, amazing, and it helps me be more productive than what I usually am. So then we're talking about human performance and human impact, which is very different when we used to think about buildings and space before. Now, what does the platform do? Our platform allows us to be able to weave information across multiple disparate systems, bring them together to create a single unified view. So we heard a comment where we started talking about microservices. What does microservices mean in the context of a building? Well, in the context of a building, it is taking data from multiple systems, making them available so that we can weave them into a single unified experience. Think about navigation to parking, to indoor location services, to room booking, to ordering your food. and finally closing out and getting back to your car at the end of the day. One seamless experience, which we all take for granted, but the amount of handovers and data points that you have is massive. So we created something called the digital integration platform. The digital integration platform allows us to bring all these data items together, create a fabric that allows us to create unique experiences which can be customized based on geography, based on cultural norms, or based on needs of the project. Every building is different. Buildings are unique. Every space is different. Purpose of spaces are different. Use that to drive that customization. At the back end, it consumes Azure Digital Twins because ultimately, like I said before, you have the spatial angle and you have the visual angle. So mapping device data to device, to space, and to human behavior is what the platform allows us to do. And for us, the architect community is front of line. You design the systems, you do the drawings, following our guidelines, our governance, and the type and naming conventions for the data items, for the data points. That then goes down to your GCs, your MEPs, which then finally, as the owner, I think the earlier comment that was mentioned, it is the owner's responsibility, and it is correct. We are able to do the digital transformation because we at Microsoft have a vision as to how we would like our buildings to operate. We define that vision, lay out that foundation, and take us to a structured approach of going all the way from the experience to the data, maintaining and harnessing that data in live real time, because that's the beauty of it. Static data is useless. Real-time integration to a digital model is what it's all about. And that's what our platform allows us to do. Mariam?
Yeah, no, I think that was excellent, Emmanuel. And yeah, I think as Emmanuel said, in fact, the GSAT integration platform, as Emmanuel explained, is integrating all these data sources. But I think I was myself, being always more on the product side, I also don't understand, right, all the processes that goes actually all the way from design to commissioning and all the way to other operations. Sometimes I'm mostly more looking at the operations, so it's actually very interesting on how the information that starts all the way from that design need to go to some sort of the structured approach, having as Emmanuel explained, really the mapping of the data and the meaning, so that ultimately can be used all the way to when the buildings are being commissioned or operationalized, right? So it's actually very interesting. I mean, in the terms also of how, we, Microsoft is ourselves, as Emmanuel explained, we're using this Azure Digital Twin platform with all the integration for IT data and other data sources, but there is a lot that goes also in the process of how you actually bring this data and really think through it all the way from design to all the way to how you operate these buildings, as Emmanuel was explaining, and how we're doing it in the West Campus.
And I think to that point too, we have members that, one member in particular, they scanned the entire Chrysler building. So it's already in existence, but now they scan that. So now they can go from something that is already existing to accurate representation. And now with all the rest of, as Emmanuel was talking and Mary, with the sensors, with all the rest of that information, and then tying that in with, as I believe it was Tony talking about, relative to all the rest of the data that is the foundational there. Now you have you have that holistic view, but you have that continual update. So now you know exactly what the situation is, and the digital twin can start right away from that, providing that valuable information and being able to, I believe, as Emmanuel was talking about, in terms of the performance, not just the building performance, but the human performance. It can identify those areas, whether it's air quality, whether it's the energy consumption, all these different aspects. So you have this holistic capability now, but you have every asset within that building now categorized, classified, qualified, and now you can continue that. And that's that continuous improvement aspect as well. And as far as education, we actually have we have a couple things going on. We have a new working group that you'll be hearing about. We're just going to bring that out to our website to the public, which is academia and research. So we have an academia and research working group we've just formed, and we're working with some of the leading universities around the world, actually through part of our liaison program, as well as with our regional branch organizers, to now identify some of these key areas and educate people on these different aspects. And as you can imagine, with the steering committee that we have, there's opportunities from evaluation perspective of the tools, these types of aspects. So we're building that all into what we're going to be bringing forward as an accelerator program for being able to have these contributions and being able to educate people on these different capabilities. So tie these all together and understand.
It's really great. Thank you. Yeah, I think all these points tie back to earlier presentations, right, on data-driven approach and having quality data to be able to get to clean synthetic data set that then we can not just use for insights, but then use for future prediction and recommendation systems, which I think is the next level, and I'm excited to see that come through. Any last comments? I think we have about 4 minutes left in the session. I just wanted to see if there's any last comments from anyone, anybody that wanted to speak on digital twins or questions. Maybe I can take one question from the audience.
And there's a couple questions in the, I'm sorry, German, there's a couple questions in the chat, and two of them is, one, what is the cost range for developing a digital twin and maintaining it? And so, and there's another one is, how do you educate clients on utilizing new models when many clients don't have in-house staff that can navigate the tools and models? So just from our perspective on those two questions, those are very, very good questions. And those are questions that I think the industry is challenged with right now and struggling. Clients have spent a tremendous amount of money and effort to build digital twins. And now to start reaping the benefits of that digital twin, that's the next step. And there are ways that they can do it. And we're working with clients, and we are using our digital twin at a very low cost for them to actually take advantage of some of it. So there are ways of doing it. It's difficult, not enough time to explain it all here today. With respect to the cost, look, as architects, we're seeing an increase between 25 to 35% in our business just on technology software. So that comes out of our bottom line. And so, we're hoping that technology improves and it makes us more efficient and makes us do things quicker, but it's still a big cost to us as an organization. But clients are demanding and wanting to see these digital twins. So there is an upfront cost that has to happen. But we have to make sure that clients are getting the benefit of that down the road so they can, get back the rewards. And there are ways of doing it. But like I said, it just take another hour, 2 hours to go through that conversation.
Maybe I can just add that, at expanding on the owner aspect, and one of the standards that we're working on in coding as well to help evaluate a project or a campus is the ANSI total cost of ownership standard, which is a compound standard, including asset management, ISO 55000 and so on. But, it's a good question. I don't have a good answer to what does it cost to do a digital twin, but we also have to consider the total cost of ownership over a long period of time, and the cost, and that cost should include the cost of the environment. So, if we take a holistic view, that I would expect the digital twin cost will not be significant if it's evaluated in terms of both the overall cost and then the benefits, both to the occupants of the building, their productivity and their health and wellness, and also to the environment.
Another point to that is, which I agree 100% with, is, we've got members that are dealing with their end customers or clients that are saying, look, we're being mandated to achieve a certain level of carbon footprint, and we're getting penalized. How can you help to address that? Can a digital twin enable that for me? Because that's really what I need to understand, because I don't understand. I have all this data coming at me, but it's not integrated. It's not in a way I can understand and gain the actionable insight to be able to make the right decisions. And so I think, again, that total cost of ownership, as these carbon footprint penalties start coming into play, it is going to be key. And that will then turn into carbon credits. And that's really what the developers and what the owners are going to be looking for. And that's only going to benefit the occupants as well.
Yeah, and maybe one point to add. I think it totally depends, right, where you want to get started and what's the value that immediately a client wants to achieve. It doesn't mean necessarily like you have to start with a complete digital twin with all sorts of fidelity. For example, I work with on the smart cities, and I hear often like, hey, do I have to model an entire city and have a replica of this, right? That's even more complex, right? So what we see, especially property owners doing, is maybe starting with, I think I heard the term of like minimal viable digital twins, kind of. So maybe in fact the focus, like there's a lot of focus to start with the energy efficiency aspect of it, right? And so not necessarily maybe to look at occupancy and other things. It depends on the priority, but the main thing is, have the foundation and architecture that's future-proofed, but really start with something small and start to get value, and then you keep adding more, maybe additional representation, or go into a higher fidelity from that perspective.
I love that. Thank you. Minimum viability digital twins. It's a great takeaway for all. With that, I think we're up on time. I want to thank all the presenter speakers here for participating as part of our conference today. I encourage all in attendance to check out their various websites, the Digital Twin Consortium, the Microsoft Azure platform, IBI's website, and Tracks for more information on digital twins. And I should also mention Trimble Consulting for more of that as well.
All right, welcome back, everyone. Hopefully you enjoyed your virtual exhibition sessions. Special thank you to the last segment. Thank you, Herman and team. So many takeaways in that segment. I really appreciate how it connected digital twins to practice, telling us how to enhance coordination, the advantages of a shortened feedback loop, and using our own practices for experimentation. That was unexpected. And I think most exciting is the prospects of the metaverse. I was not expecting that introduction, but apparently it's here, everybody. Up next is a discussion on technology and the construction industry. Are robots really taking over in the field? What does advanced technology in construction mean for our practices? Here to school us on growth opportunities and changes that can improve our services and deliverables, let me introduce Corey Brugger, Chief Technology Officer at HKS. Corey is an industry-recognized expert in developing and integrating innovative technology and architecture in the built environment. As CTO, he directs the vision and team dedicated to developing and deploying advanced technologies and new processes for design and construction. Corey, over to you.
Thanks, Nicole. I really appreciate the conversation to date, and that last session was really just touched a really good point from where we're coming at for today's conversation. When Tim said that we've been creating digital twins forever, right? Whether it's the drawings, the models, and I think that that's really at the foundation of the conversation today. Is that as our industry evolves, as we become part of a new process or part of the champions of new deliverables, we already have the artifacts and the assets that can help us develop better products or provide more benefit to our clients. And I think, what we wanted to talk through today is how do you leverage that? How do you really build an opportunity for us as architects to play a broader role? And to set that up, the reality is that we're all heading in the same direction, right? That's the goal. We have a city that we're planning. We've got a building that we're planning. We've got a space that we're planning. And in our current state, right, we're distributed. Everybody has a piece of that puzzle. There's a lack of standards. There's a lack of communication. There's disparity in the tools that are being used. And at the end of the day, in between each of those communication cycles, we lose opportunity to provide value or to provide benefit to our clients. And I think as architects, what's most important for us to think through, since we control some of the most important assets around, when we're talking about digital twins, we're talking about the ability to leverage data that already exists or already can be tied to models, then it really gives us an opportunity to rethink the life cycle of a project, right? And if we were to look at each of the stages, where we play as architects is a really small part of that. When we start looking at from marketing, marketplace analytics, all the way through decommissioning of a building, we really have a small percentage, maybe 1 to 5% of the life cycle of a project. And the reality is that range of the project has the most influence on its long-term health, on the clients and on the users. Right now, we tend to have less influence in the construction process than we really should have when we start to think about the artifacts that we deliver to a contractor, right? When we're starting to think about going beyond design intent. And so what we wanted to set up in the conversation today is how or where can architects start to leverage the assets and artifacts we already have to help influence or benefit our partners in that process. And so with that, we'll start with looking at what some architects are doing as they're moving into design build. And I'll pass it over to Brian Skrpak to really talk through how design build really gives us an opportunity as architects to contribute to our trade partners and to the success of the construction process.
Yeah, thanks, Corey. Hi, I'm Brian Skrpak with the Design Build Institute of America. And when Corey and I first started, and Javier first started talking, one of the interesting perspectives that came up is not only looking at it just from this conversation from just an architectural perspective or just a construction perspective, but really one about the built environment. And when we kind of look at that broader scale, there are really 3 themes that I wanted to point out here, quickly. And that's one of moving from this traditional design bid build to a more collaborative blurring of the lines in a design build scenario. Another conversation of a traditional stick-built construction to on-site assembly, which I had the opportunity in my previous role to work on a couple unique projects that really started to embrace this. And it were these things that were really building upon one another, transitioning into a design build delivery, leveraging this prefab and industrialized construction mindset, and then starting to look at how these tools of our transition from the 3rd to the 4th industrial revolution really start to connect all of these things and create a continuum as we move forward. So for a little deeper dive into the first one, I think it's important that we look at project delivery as really one of the foundations. We all talk a lot about the digitalization of the industry and the transformation of the tools that we have, which as we've seen today are fabulous and can do significant things for us. But we're all still really limited when we're in a project delivery model like the one on the left that we're seeing. We're stuck with this very linear delivery plan. We have 2 major contracts instead of 1. And the designer and the designer and the builder are still not really contractually obligated to do anything, right? They have these 2 separate contracts back to the owner. We start to look at more collaborative delivery models, like in design build. This is where we can really take advantage of. You have 2 main players in the contract. You have the owner and the design builder, and that design builder is really the leader of the team that we have, which includes all of the key players. When we have all those key players at the outset of a project, we really have the opportunity to accomplish much more than we have traditionally, and we can really bring the right team members to the table when they're needed. And that starts to open a lot of different avenues for us to collaborate and work more effectively. And one of those is this idea of on-site, moving from the next slide, Corey, and moving from the on-site assembly from a traditional stick-built construction. A couple projects that we've done recently, working with different prefabricated structural systems, prefabricated exterior wall panels, to actual volumetric rooms. Not that those not load-bearing, but really being able to take and fabricate what you see in that middle image is really about 3/4 of the rooms in a 3-story building in LA County. And having that building replicated across the site allowed us to build 120 rooms prefabricated in the middle of the country in Kansas and ship them out to the job site in downtown Los Angeles. And that takes a lot of coordination, whether it's something as simple as a wall panel or having all the MEP systems in a room and starting to plan out how you're going to connect those to the rest of the design systems with the design build team really takes a lot of planning and opportunity. The technology is there to allow us to do all that, but much different scenario if you were trying to do either one of these solutions in a design bid build versus a design build project delivery model. So I think this is, again, another opportunity where we're seeing the blurring of architecture and construction, and really seeing the merging of those two and the overlapping and a higher level of collaboration. And as we continue to move forward, that convergence of all of these tools, all of these ideas and expertise really start to bring us additional new opportunities. So we already touched on one about in industrial production, right? All of these prefab things that started with very simple mechanical racks are now moving into entire rooms, facades, and larger components of buildings. And it's becoming more and more impactful to the speed in which we deliver these projects, as well as the quality in which we deliver these projects. When we talk about these larger cyber physical systems, as Nicole mentioned in the beginning, we see more and more robots. We see Spot the robot. We see, what Doxel is able to do with their robots. Dusty Robotics. There's all these tools that are out there now that are roaming around the job site that are helping us move forward and become more efficient in the work that we do. And then I think the digital technologies and computing technologies is really that ubiquitous access to information that we have. We have all these tools that can be connected and accessed simply from our phone, and being able to have a speed of which we can, see what was designed, being able to overlay that in an augmented reality perspective on the job site, and be connected to ask questions of our connected teammates and move forward. And when we start to put all these things together, we really have tangible outcomes. The old equation of schedule, budget, and quality, pick two, really starts to go away. Now we can really start to embrace getting all three legs of that stool and not just being minimalized to the two low-hanging fruits, but create a much better environment collaboratively, and not being in a siloed environment from the design and construction side, but really creating value for the owners that we're building these buildings for, and hopefully making more sustainable buildings that operate more effectively and efficiently over the life cycle, like Corey was talking about.
Perfect. And now I think we'll move into not just the side of architecture and contracting, but then the really where the assets, the models become foundational to the communication with fabricators, the coordination and sequencing of installation, right? How do we support all of the logistics of getting our projects built is just as important as how we detail and how we design. And so I think with that, Javi, if you can jump in and just walk us through where you guys are supporting, augmenting the role of the architect with our trade partners and with our clients.
Great. Yeah, thank you so much for this opportunity. Nice to meet you all. My name is Javi Glad. I'm from CAD Makers. And today, as Corey mentioned, I'm going to talk more on the lens of the A of DFMA, so assembly, and that whole site logistics piece, and kind of helping support that with digital and collaboration tools and stuff like that. So to do that, I'm going to just dive deep in, well, not that deep, but I'm going to talk about a cool project designed by ZGF and KPFF on the structural side, and Hoffman Skanska were the two main contractors. This is the Portland Airport. Some people may have seen some information about it recently. They did some kind of media, it's a pretty incredible feat of engineering. Our customer was Swinnerton Timber Lab, but we all kind of worked really collaboratively together. And the architects and engineers did just an amazing job. The people on site did an amazing job. So we go to the next slide, and then this is just kind of like a quick overview. Hopefully it plays. It's supposed to play automatically. Oh boy, we're already off. Here we go. So just to give it's a little bit grainy, but to give an idea, each one of those cassettes or drawers are like a football field long, just to give some concept for scale. And what's really interesting is there's a couple things that will be fascinating. So the mass plywood panel roof panels are kind of cold formed into place. So they're fabricated and they're bent into place. So one of the first challenges was thinking about, okay, you give information, BTL file or whatever file to machine. We kind of had to reverse engineer some principles from sheet metal, and even one of our leads on the team has done Class A surface modeling. If anyone is aware of that, it's like a car hood, right? So like really detailed modeling. Not that we went to that level of detail here on the MPP, but those kind of principles of like almost unfolding a mass plywood panel because it's kind of fabricated and bent into shape, but the tolerances are so tight that you have to start simulating how it comes together. And moving things around in space to see what it looks like. So this video is just really to give you some kind of idea of the scale of this structure and the amount of detail in there. This next one is talking about the first few iterations of using digital simulation to validate on-site assembly and if some of the design systems are going to work. So this is an interesting use case that it's hard to see. We got a typical kind of detail with regards to these kind of connections, these steel connections. And as you can see there, what's hard to see until you start modeling and simulating is that there's curvature coming into, compound curvatures coming into this. So this lattice has kind of a curvature, and you can see all of a sudden there's like all these gaps being formed, right? So simulation here was used as kind of a next level to say, okay, well, wait a second, that was, the typical detail, first of all, needs to be revised, and they ended up having many iterations of, many different instances of different types of connections. But also by simulating, putting it together, you can see all of a sudden, like for example, in this case, is a pretty big issue. You got a curved mass plywood panel and a flat plate that you're screwing it into, right? So obviously this doesn't work. So part of this was iterative as a team, collaboratively using the simulation to go back to the design team, the structural engineer, the installers, the fabricators, and saying, okay, what are some changes we can make, right? So, okay, we're gonna have to change how the screws are going to be drilled on site. And then, this is, we didn't put in this video, but even like simulating, ergonomics, like, can you actually reach some of these areas, right? And stuff like that, which was pretty cool. So this is kind of the first level of using, there's lots of simulations that went into trying to validate that the design intent and then the fabrication information was buildable. Then there's this next step, which is really cool use case. And it's just, again, an amazing feat of design and engineering. So the idea here is they kind of, because it's an airport that's operating, they can only do installation at certain times, when planes are not coming in, so in the night. And some of these, like some of these drawers are being prefabricated elsewhere and being brought onto a yard just off to the side of the airport. And it's being pre-installed. So you're being pre-installed and then moved into place over the night. So what this simulation is showing, which was pretty interesting, is we kind of disassemble the final assembly and then start validating like a kinematic simulation of how it would move, right? And what was really interesting is because, again, some of the curves and stuff like that, we had to kind of work with the team to change the design of the structure and the parts, how they come together, to be able to be moved. Because the big risk here was, it's a huge amount of time, effort, and cost to plan moving this thing, and it's in the middle of the night. And if there's a clash or there's some sort of issue when they start moving the drawer down the way, it's like unbelievably disruptive to have to put it back and go back to the drawing board and start this all over again, right? So I know the theme of this talk is around digital technologies kind of helping, aiding, and assisting the built environment and efficiency. This was a great use case of this, right? So like it's not something you see every day. We're going to build a football field worth of a roof and then we're going to move it, however many, it's pretty far actually. And so this is kind of repeating a little bit. You can either speed up this video. But the next one, there's another part about how it actually slides, the drawer slides. And we had to like help with the team to change the design of the structure in a few areas so that the steel wouldn't clash as they're designing it. So the next one here, you're welcome to scan that QR code if you'd like. So those first few videos, a lot of what we do as technologists in the construction industry is what, especially in today's day, is what we would call high effort, high value, sometimes high total cost solutions, right? So those first ones, so a lot goes into it, takes time, it's difficult, and you kind of get a video at the end of the day. So we're talking our own book here a little bit, but this is our own product that we built called CM Builder. And one of the main drivers of CM Builder is trying to make this information accessible for the people on site. So instead of having a video where the superintendent says, hey, wait, pause, can I look at it from a different angle? Well, I can't, it's a video. So it was really hard to make this video, and it's not like super easy to change. With every installation drawing, and there came a work instruction package that had a QR code on it, and they could just scan this with their phone, and they can run the simulation directly on their browser. They don't have to credentials. They can stop the simulation. So you're welcome to like press pause and fly around. You can take a section, take a dimension. And this was like adding another layer of accessibility, which is kind of my big lesson learned over the last few years. Is all these great digital technologies have been getting better and better, but I think as product builders, we haven't done the best job of making these tools accessible for low tech folks, right? And superintendents and construction folks that definitely want to leverage technology, but are not going to be able to drive many of the tools that are currently in the market being used by construction folks. So this part of it was like, how do you, and so there's the master assembly model was made available for everyone on the team that can just, scan the QR code or run a link, runs in the browser with many different simulations for different aspects with call outs. And here they're thinking about temporary resources, like, hey, what types of temporary resources and what type of human resources are we going to need to perform the work, right? The means and methods on top of the model itself, right? So, so that's about it. And I just kind of finish up, again, this is just one of the coolest projects I think we've ever been a part of, and just unbelievably challenging in terms of design and engineering, and thinking about like you're fabricating a part, but it's going to get moved, and it's going to the shape's going to change, and if you're bending MPP and into place, what is the angle of that so that doesn't like catch, or it doesn't have a clash, or it doesn't have a so from Timber Lab to Swinnerton to the whole team, just an amazing collaborative effort. And just a few more images to show kind of some scale. This is from last week, actually. We put a little mannequin there to pretend like there's your digital twin of the guy. But yeah, that's it. So just the big kind of lessons learned where making the model and the simulations available to the superintendents, the foremen, to the people that are doing the work was unbelievably valuable. In terms of, you mentioned feedback loop, we had just so many more great ideas coming from the team when they could access the information and they could kind of consume that in a more dynamic way than just like videos here and there. So that's about it.
Awesome. Thanks, Javi. You know what? I want to ask the first question, which is, there's always been this separation. Brian, you talked about it in terms of the contract side. There's the limitations of means and methods. The reality of what the industry needs us to do in terms of delivering better information, more accuracy, and more rigor in terms of those assets, so that we can get to a level of a level of completeness and communication that isn't about intent. It's about the actual, right? And I think we've heard that across all of the presentations today. It's available, the tools are there, the technologies are there, and the opportunities are there. And so being an architect, being around architects, and this being a presentation for architects, how or where do we get, or how or where should we get more involved in supporting our construction and trade partners? And then what are those opportunities for educating our clients or engaging and collaborating with clients to make sure that the delivery methods and the assets we are creating are being leveraged to the kind of most, best use possible?
Yeah, I think it just comes down to, it comes down to early planning and collaboration. I think historically there's, and I know I saw this in a firm that I had worked at previously, a project, this was about in 2012, where we were going at it as we were the architect, the engineer, and the construction manager, and trying to get past the historic adversarial roles that everybody had. This kind of idea that technology is easy, people are hard, really came through. And my boss at the time would sit there and be like, there's a reason we're all sitting in the room together, right? You know what your design intent is, and he's over there telling you this is the issue that we're going to have on the job site, and she's a civil engineer telling you that we can't situate the building where we need because of contaminated soils. So if we all talk together, let's come up with a solution with where we're actually going to move and situate this building and resolve this issue at the outset. This is a point where we're looking at early parking, sustainability, building form, shape, situation, and now you have this wide range of people that can contribute to that conversation and give their expertise early on. No single discipline's a silver bullet in designing perfection. It's a collaborative team effort. So why not be able to take advantage of those those ideas and realize that we're all working for the benefit of the owner. We're not necessarily looking out for our individual interests, but we're still all working for the same. We're all working for the same person at the end of the day.
Yeah, I would build on that. One trend I've seen since we started the company 8 years ago this month, actually, when we first started, there was very few architects at GCs. It felt like, anyways, because the technology kind of VDC thing. I mean, there's probably a lot of early adopters on this call that are like, oh, we've been doing this for a long time. But I'm thinking at scale, there wasn't a lot of GCs doing lots of modeling and digital stuff in 2014. Now you fast forward, like almost all the main customers we're dealing with, especially on the product side, happen to be architects that are working at contractors now, right? And bringing VDC and technology into those firms. So I think first thing is that's a real benefit to understanding the perspective, right? If you have an architect who's worked in practice and now works at a general contractor, they're probably going to be more empathetic to both, to that situation when you're working on a project together and understand how to look through the lens of an architect when making those critical decisions. On this project here, I think it's almost a bad example for that question, because I think everyone started this project knowing it's just so unbelievably complex. There's no way that anyone could know everything, at any point in time. It's truly going to take, which was an amazing collaborative effort from ZGF and KPFF and Skanska. We worked very closely with them. Swinter. Everyone was trying to help, and it was just so complicated. And I wish we could take that kind of what happened here and just scale it to every project, because every project has its complexity, whether it's big or small, right? But I think it's like almost maybe it's our preconceived notions. Like starting this project, everyone was like, we're expecting this thing to be unbelievably challenging, and it was, and it is. Whereas like maybe sometimes we start on our typical project and maybe you don't have the same expectations, right? Then it causes people to maybe a bit more just figure it out, like, figure it out on site, and, sending back and forth, questions and queries maybe, and it gets more adversarial. But overall, I think that empathetic perspective of more architects becoming on the other side and the contractor is going to help. And I think this move towards design intent being a starting point, but like means and methods and actually on-site assembly being critical is definitely something that's going to continue to go on, and I think will help everyone on these projects.
Awesome. While we're waiting for other questions to come in, I think that there's always a preconception that the collaboration and coordination when we go into construction or fabrication is added risk for an architect or for our engineers. And, I'd like your take on that. What is the added risk of leveraging your artifacts in construction, or having somebody else try to interpret what your intent was versus actually being a partner in that process?
Well, I think the risk should almost be a fallacy, right? I mean, you put contract documents together. The contract documents should come from the model. So why have that feeling of risk? I think from the design side, we need to put that responsibility on ourselves to be true to what we're doing. There's no why bastardize modeling something just to turn it off in a orthogonal view and trace over it and create that inherent disconnect in the documents that you're producing. I think that's a real struggle. I'm like, that just seems like that seems like a waste of time. That is a waste of time for me. I've defended that for years in the firms that I've worked at. So I think that's a challenge. I think the opportunity for the design professional was to say, this is my design intent, and focus on what needs to be achieved, and allow the, you know, those sub trades and subcontractors and specialty contractors like a glazing contractor, a metal panel manufacturer, to really understand how those systems come together, and not waste time just drawing details upon details upon details, when you could focus on a more generic representation of design intent, form, you know, dimensions and shapes that you're trying to articulate. Let them bring that expertise to the project and advance it as needed. That makes everybody's life easier.
Yeah, I guess the definition of risk, it could be looked at in different ways. You know, I think you're hinting on the obvious, like litigation type risk, or contract documents, or sharing information that someone builds from that's not supposed to be the right thing you're building from. And there's obviously very clear lines on what's allowed, not allowed, and all that kind of stuff, and what insurance will cover and won't cover. And so that's a hard thing, and I'm not going to pretend like that's an easy thing to manage. But one thing I have seen is more and more, especially on the CA side of an architect's contract, you know, there's also massive like financial risk when you're spending 6 turns of shop drawings, right? and you know, like that's a risk, right? And I don't think anyone that's doing it wants to. And probably a lot of that, I mean, we've had some projects go well and some not go well, but the ones that went well, where, yeah, when you have a much more integrated way that you're working with that, say, design model, and then bringing it to more detail downstream, and having more of like a model-based approach, it can like definitely reduce the number of turns back and forth, right? Because revise and resubmit is one way to do it, but it's another way to just like, here, we're speaking the same language here. We're trying to achieve the same goal. And when it goes well, it's really nice, right? You submit, the shop drawings are submitted, it's reviewed and approved, and it's like, wow, you know, that's like, you reduced your financial risk on the project, you reduced your reputational risk on the project, and likely you're going to get a better end product for your client. So, but that legal risk is definitely something that keeps hanging around, and it's a real challenge.
Well, and how embarrassing is it to get that RFI from the contractor and say, well, where is this thing actually located? Where it's at in the model, or where it's at in the drawing? And nobody wants to get that one, but it happens all the time. Yeah. Just model it right.
Perfect. We're unfortunately out of time, but I wanted to thank you all for joining us and really providing some insight and expertise on how, as architects, we can really contribute to streamlining and improving the fabrication and construction process. So with that, I'll hand it back over to Lauren.
Thank you, Corey and Brian and Javier. I agree. It was really interesting to see kind of how digital technologies can help in the field of construction. And now we're going to move on to our virtual reality and augmented reality panel. I'm very pleased to introduce my fellow chair of the AIA LA Practice Committee, John V. Kanani. And John V. is an architect and BIM professional with 16 years of architectural design and planning experience. And she specializes in educating clients and consultants in the use of technology to address project issues, and brings her diverse experience in design, technology, and sustainability to deliver integrated design solutions for her clients. So welcome, John V.
Well, thank you, Lauren. Firstly, I want to thank everybody for joining us today as we kind of discuss the immersive technology and with some of our subject matter experts in our industry. So for this panel, we will be discussing the use of technologies like virtual reality, augmented reality, from design through construction. So I'm joined by our panelists today, Rory Mitchell, a director and producer for VR and AR for a local Los Angeles-based company, The Mercantile. He will be discussing architecture and design as defining disciplines of spatial computing, and will also share some free tools that we can use in our practice today. He'll be joined by Daniel Ayers, design principal at NBBJ, who will bring his global experience to how immersive technologies are being applied in design today. Also joining is Dusan Salzan, the VDC manager for Balfour Beatty. He will be sharing how VR and AR is leading its way in the construction industry today. So a little bit more information kind of ties in well with our previous presentation. And finally, he's joined by Renzo Di Fiore. He's an owner of RDF Consulting Services, a former regional VDC manager for a large international construction company. Renzo is focused on continuous improvement, applied research, and supporting construction technology career paths. He will be discussing some of his work in today's panel. With that, I'm going to hand it off to our first panelist and they're going to tell us a little bit about themselves and their work. I'm going to hand it off to Rory Mitchell to kind of lead this discussion and present his work a little bit. Thanks.
Hi, everybody. Hi, can you guys see this screen? Apologize, I'm kind of fighting off a bit of a cold here, but
yes.
Okay, great. Yes, that's me. I'm here to speak to you about smart cities. We've used some lovely Adobe stock photos in here. I'm with the Mercantile Agency. We are a creative agency that not only uses AR and VR to kind of help people tell their stories, but we also tell stories about AR and VR. So we've produced a lot of content for folks that are using AR and VR. So we've just been doing a lot of this stuff for the last bunch of years. And I'm going to both talk about AR and VR, how they interact, and then give you guys a couple of tools that you may already be using or you may not be. But this is kind of like a general omnibus conversation about this. The tools of tomorrow today. I think a lot of these Adobe stock photos are pretty interesting as far as just like, you know, kind of getting at the nub of what we think of when we think of this stuff. You know, these are some off-brand VR headsets and they're, you know, it's kind of doesn't work. I don't know. It's the same people in a bunch of these things. And here they're using AR to look at the same, to look at the same digital city. I think that it might be more helpful to think about AR and VR along a spectrum, as opposed to two distinct things. AR and VR being at opposite ends of the spectrum of computer-aided design. So on the far right side, you have reality, which is your ordinary reality. And then augmented reality is really just adding in a few computer-generated elements into your reality. Some examples of that are kind of snap filters or Instagram filters or Pokemon Go. Mixed reality is basically augmented reality, and then virtual reality, which I think a lot of you guys are very used to and use a lot, takes over your entire view shed in order to, with computer generated or alternate realities. So I think it's helpful to not think of VR and AR as separate things, but just 2 points along a continuum. I'm also here because I think it's exciting to, you know, I'm not an architect. I don't know much about architecture. I'm fascinated by it. I'm an appreciator of architecture. And I think it's important to get more of you guys not only using AR and VR as tools in your own practice, but also designing and building things for VR and AR and for the metaverse, which is our hot word these days. And I think we refer to XR and AR and VR as spatial computing. And really what we have here is just an opportunity to tell stories in space, which is what you guys are all so good at. And I think that, you know, thinking of architecture and design as really the defining discipline of spatial computing, or the metaverse or XR or, you know, whatever. I mean, I think the metaverse gets a lot of attention these days, and people are like, oh, what is the metaverse? Well, you all know what the metaverse is. It's all, you understand innately what the metaverse is. It's the same thing we've been seeing all this time. And you guys are in a wonderful position to kind of help push the field forward. You know, I think one of the premises that, you know, I'm developing for a little while, I've been developing a 360 or VR experience that would just kind of educate people and take people inside various architectural elements and stuff, and just experience stuff from inside VR, notable architects or what have you. And part of the insight there was, you know, architectural photography became an art form in itself, in an attempt to kind of document architecture and its space and use of space and all of this. And really what VR and AR gives us is an opportunity to go directly to the source, which, you know, isn't new for you guys, but I think it's something that we're starting to kind of evolve a little bit further. Here's I think you guys are probably all used to panoramic 360 photos by now at this point, but this gives just like a beautiful view of how things come in there, and the fact that you can put on a VR headset and you know, be in this space is an incredibly powerful tool. Right. So like I said, we are a creative agency and production company. We've worked with all sorts of brands, from Facebook to General Mills to Honda and Target and Disney, and everybody kind of doing various VR, AR, 360 stuff. But, you know, we started back in 2014 making a tour of the Kettle One distillery. And this was another just a great example of how VR can transport you to spaces. That was an interesting promotion because Kettle One actually attached the little cardboard glasses to bottles of vodka and sent them out, and people could pop their phone into the cardboard and take a tour of the distillery wherever they were. It was interesting as far as bonding people to the project. So my work with 360 video led me to be an advisor for Open Space, which some of you guys have probably run into at this point. Open Space uses a 360 camera attached to a helmet. And this is actually a video that we produced for them at some point. The 360 camera attaches to the helmet. You walk around your job site. You've uploaded your floor plans ahead of time. You tap the point on your floor plan and you walk around, and it automatically generates a Google Street View for a construction site that you can then use to collaborate remotely with people, and all of that. That's been important over the last few years, as I'm sure you guys are aware. And they've now expanded their offerings to use AI to kind of track job progression. So they're using machine vision and AI to you know, just track progress on jobs with their ClearSight tracking. Sorry, that's an exciting drone shot that's got really amazing music. And this is the segue to my next slide, so I'll let it play out like this. Open Space has a free option called Open Space Photo. Open Space Photo, and if you have a 360 camera, you can use Open Space Photo for free. You upload your floor plans, you can walk around, and it's helpful for documenting a site before walls get cleared up and all of this. It's basically a time machine for your job. We do a lot of drone stuff, as you can see here. This was a shoot that we did last year at some point in San Diego. So it's the lovely San Diego skyline. And using drones has led us to doing a lot of aerial photogrammetry as well. So this is a building that is going up downtown LA. And we used a drone to just make a 3D model of this site. You can see as you get a little close, it gets a little muddy, but you know, it's a remarkable technology that's available now. So we're a big, we love drones and using drones for all sorts of things. But this process of photogrammetry, you know, you guys are used to it with laser scanners and all of that stuff. It's also now something that you have access to in your pocket with your iPhone. These are a bunch of free scanner apps that also have more, that also have paid options as well. But you can use these to scan something in just a few minutes. Polycam, most of these use the new iPhones that have LiDAR on the back of them. Polycam will just work by taking a bunch of photos. So that's you can use that even if you don't have the latest iPhone with the LiDAR. Here are just a selection of some scans that I've done recently. This was using every point on my pregnant wife. This is a point cloud of her. I kind of just walked around her and scanned her as she stood there. This was a box that a friend received that had a antique pre-Nintendo Japanese video game system in. So I thought it was an interesting box and kind of cool. So using Scaniverse, we made a 3D mesh of it. This was some office space I was looking at. It's messy, but if I had taken more than 2 minutes, it would have been a better scan. But it's useful because you can also get rough measurements on this. So I was able to, in speaking with folks, I knew how much space these catwalks took up right there. Here's some basement electric cabinet that we scanned for a project. And this is a chair in my office. And what's interesting about this and all of this scanning stuff is that you can then take these scans and drop them immediately in augmented reality. And not only that, you can text these to anyone else with an Apple phone and they can tap it and look at it in their in their space as well. So you could conceivably like scan pretty much anything, text it to someone, and they can drop it and see it to scale in their space. Yeah, and so that is just a bunch of the stuff that we've been doing. I always love talking about this stuff. Anybody who's curious to talk more about AR, VR, and how you guys might use it, always happy to throw out ideas and brainstorm. And thank you guys for having me.
Thank you, Rory. With that, I'm going to hand it over to Daniel.
Thanks. That's it's so much fun to see other things outside of just seeing architecture all the time, Rory. So great to see, and a good segue. Can go to the next slide. I want to run through a couple of things. When we really started diving into talking about VR, AR, I thought what Rory just outlined with the fact that we're all working in it in very different ways. A lot of us are all using it. I wanted to hit on a couple of things today about how we've kind of taken it, but then starting to find ways that we can work within it. And that's kind of these hacking the VR. Some of these are older, some of these are newer things we've been doing, but I thought just might spark some interest and discussion around kind of how we see technology continue to evolve and how quickly the technology can come in and be gone and changed in the next time. So go to the next. So I know a lot of different places use kind of hackathons. It's kind of come out of the IT world and kind of approaches to these 24-hour kind of working sessions. This is just an image of us working, late at night, trying to come up with different ideas and different tools in a very short amount of time, kind of that fail fast. So this is a quick kind of what came out of that hackathon and how we started to investigate ways of working. So go to the next. Within our hackathons, it's really, leadership across the firm coming together. We create different pitches and different approaches to how technology is coming in. In this case, we really focused a lot on the VR and AR and how these tools could be utilized in different ways. Go to the next. And three of the things really started to develop. It should be tool 1, 2, and 3. Somehow it ended up tool 1, 2. Always fun to do in PDF. So going to the first tool. Hopefully the next slide goes to the video. So in this case, it's we've seen, and it's actually been discussed today a couple of times of how do you start to bring things down? How do you work with our digital models in different ways? And from all the way at the beginning of a lot of the discussion of the data, how do we start to see that data, review it, work with it with our clients? And in this case, how could you immerse yourself in a space that is starting to look at both whether it's daylighting into a space, usage of a space, but using VR in a different way than putting on your space, but actually being able to modify your model, change through different options and different settings within the model, and all through using the same tools we already have and the same headset that we already have. So it's an option of kind of looking at VR in a different way. The second tool, go next slide.
was, for MBBJ, we do a lot of healthcare design. We're always working and looking at how headboards and how we're working with nurses and doctors in the patient room. And in this case was an option of how could we do this virtually? We build mock-up rooms all the time. We test this stuff out, but imagine being able to, before you actually do those mock-up rooms, you can actually test out some of these different aspects. And that was a very rough tool, but I think gives you a fairly quick idea of how you could start to work with these elements and work with your clients in a way that could be quite different than just, again, looking at a space that you can't move. This tool actually ended up turning into taking the physical mock-up of the space and actually moving it around and not going back into Revit. This one's also being able to design in a space. How many times have we been in a VR going, oh, the ceiling's too low, or wow, that windowsill isn't quite right, and going back to the model, changing, and then coming back into VR. Why can't we create an environment that we can actually start to modify these things in real time while we're in the space, change out the furniture that's in there, test the different things with the client in more real time with them, and changing kind of that look and feel. So again, just 3 tools that just started to play with ways that we can interact better with a virtual reality model. And go to the next. So some of this ties into a tool that out of all these kind of quick studies, we really started focusing in on what was called Visual Vocal. If any of you have used it, you'll know that it's actually no longer being used. But I thought it was a really interesting case study of a technology and a process of how we went through trying to find ways to interact with our clients. And a lot of discussion today has been about the visual and how you move around it and how you kind of use it. The added layer that I liked about this was we added in the ability to add voiceover. So we can have, talk through with our clients on the options. It sends them a notification to their phone, and they can look at their phone and then use goggles with it. So go ahead and just flip through these. There's a bunch of slides. We'll just kind of hit through this pretty quick, but it allows it to be a little bit more engaging for larger stakeholders. We use it with community groups, use it with clients. Go to the next. We started to play around with, in this case, this is an example of a master plan. Again, community could start to engage with it. We can start to use actually very simple technologies. So go to the next. This is taking, similar to what Rory was talking about with 360 panos. Whoa, that's moving really slow. And go to the next. Now, static 2D renderings give you a certain amount. You can take a 360 view of an existing space. You can see there's a button in the middle. You have a future version. If you go to the next slide, being able to immerse them in a quick view of a 360, then this is the potential what the view could be. You can add a voiceover of saying, now you can see this parking lot's been changed into a nice green open space. Client can give their comments back in a recorded response. So you can have a dialogue, and during COVID and other times has been a great tool that we utilized for this. Go to the next. And just another example of kind of that current state. And really slow today. And so the tool itself is very simple. The idea of these goggles we would give out to our clients, and it was just a very simple tool. Started getting into the construction industry, being able to document different areas, very similar to the digital twin. So it's kind of interesting how all of this starts to tie together, being a very visual industry that we're in. So I think one more slide. And this was just kind of showing how some of the different options. So hope that was interesting. Just a couple of different approaches to how virtual reality and different ways of trying to interact with our buildings and with our clients.
Thank you, Daniel. Dusan.
Good afternoon, everyone. Just checking. Can you hear me okay? Perfect. Thank you. So my name is Dusan Selazan. I'm with the Balfour Beatty Construction. If you're not familiar with Balfour Beatty, we're a larger education building throughout California. And then also we perform quite a bit of a public work as well as some correctional facilities and county and state work as well. So going about technology, how do we pick technology? When do we buy? It is a price driven, definitely. When it's affordable for construction, that's when we go and buy. Keep in mind that none of these technologies were originally created for construction. VR, 3D modeling, everything else was originally created for other industries. And then once it became affordable and more customizable, that's when we started adopting, really. And now the question is, we have a lot of software out there, we play, we test out, but what is really bringing the benefits? What is the bottom line? Is it bringing the benefit to the project? Is owner willing to pay for that? Are we willing to pay for that? And is it something that's really improving our processes or not? We test a lot of software that we figured out at the end of the day is just going to cost us more, and it's going to take more time to use it than what we're doing right now. So just wanted to, if you click next slide, just wanted to show you a price difference on the virtual reality set from 2012 and today. It was $25,000 to purchase a VR set back in 2012, and now it costs us $600 for Oculus Rift 2 or Google Earth. Google Cardboard you can probably get for free. So this is one of the reasons why we're seeing use of technology throughout construction, throughout architectural firms and everything else quite a bit. So next slide, please. Talking back to that bottom line and what are the true value when we do purchase this software and when we try to implement it. Well, first one is a client satisfaction, right? As I mentioned, we do a lot of schools, we do a lot of jails, and some of these users, some of the owner representatives, they never build projects in the past. They're going to do one project, they're never going to build it again. So how do you engage them? How do you involve them in the process? Because most of your decisions that are going to be implemented on the project come from there. You need their input, and what is it, that's going to bring their interest? Well, just showing them a 2D drawings, or even, showing them a BIM model, get some satisfaction, but not as much. That's when we started really using the virtual reality to fly through the models, through the future spaces with end users, with the owner representatives, to try really to get their buy-in early in the process, to get them engaged, to get them excited about the project so that we can work throughout that process, on everyone's best side with the best interest. So this is just a samples of some of our school projects where we would bring, the department heads and also the principals and tell them, this is how your space is going to look like. Please try to understand it. It's hard for you to read from 3D drawings, but being able to put a goggles on and really feel the space, try to make those decisions if you like something, if you do not like early on. So now this, from the general contractor side, this works very well when we're on a design build projects or design assist, but then you get into situations, right, when we're brought in very late in a design or when the construction is almost to start, then there isn't really benefit of doing this because design is already set and done. So next slide, please. This is an example of our design build projects for the Kern County Justice Facility. Again, having a sheriff department engaged into the process wasn't easy at all. But we did bring VR sets. We wanted them to get a feeling for their future facility that they're going to be managing, and the feedback was very positive right away. They could feel the space. They were checking for any hidden spots that the inmates could hide, for any blind spots. They were checking the widths of the corridors, that they wouldn't really get a feeling for the size when reviewing 2D drawings, and the design decisions and changes started happening right away. So that is really one of the big benefits that we saw on these particular facilities. Also, someone before me mentioned about the virtual mock-up rooms. We're obligated to create mock-up rooms on site, and for the purpose of if everything works fine, to get a feedback and then to repeat that same room multiple times later. Well, even that single mock-up on the site for cell costs $50,000. So if you can have a virtual mock-up of the mock-up, can still save you time and money and bring benefit to the project. So this was a good example of creating that virtual mock-up of the cell for this facility. Next slide, please. Going back, one more click, please. Going back to educational facilities and talking about changes, right? I mentioned that design was already done, but now we're starting to build, and there are changes that are happening throughout construction. Reviewing some of the changes that might lead to a larger change orders and design changes was also helpful, bringing VR to the owners and to decision makers and flying them through the models and doing that in the immersive environments. This is an example of finishes meeting, right? We were on a design build project for County of San Diego, and we needed to get done with having, I believe there were 5 different departments and users selecting and choosing their finishes, right? So each department has 3 representatives. You multiply that, how many people are there to make decisions, right? Some of them never experienced process like this. So how do you show them and how do they make a best decision to pick a carpet that they want, to pick furniture that they want, solid surfaces, and so on. So we gathered all of the samples in our room, in the big conference room, and then we had a multiple design differences that architect prepared with us, and we were able to fly the owner representatives through their, dedicated offices to ask them what color of the wall they wanted, what carpet style they wanted, furniture, and so on. And I think usually what I got from architect that these meetings and decision making sometimes takes 2-3 weeks to pick up all the finishes. We were able to do it down to 2.5 days. So just talking about some of the time saving by being able to fly through the VR. Next slide, please. And then moving on to construction. What is the true benefit of having VR on construction? As I said, we tried a lot of different software. We tried software using VR for punch lists. That didn't really work because you got to spend 10 minutes on creating a punch list via VR when you can do it in BIM 360 in a minute, right? So yeah, it is cool, but it's not really practical. We tried using VR for coordination meetings for BIM and clash detection, same thing. It takes way longer to do that than just using an Navisworks. So everything has its pros and cons. However, some of the really cool things is the safety trainings. This is our group in Hong Kong. They created a safety training through VR. So all of the workers, before getting them on the site, they have a Google Cardboards and they're doing safety training site specific in a VR mode for their workers and employees. Next slide, please. And then just thinking about the future, where is savings and what we can use to improve processes, creating a safety training or scaffolding training for the VR, AR, if you're gonna. I was a part of the AGC San Diego new facility board. So we were trying to figure out what are the ways that we can save on space, first of all, and then to still have the minimum safety risk and to be able to get more people through this training faster. So creating welding training, some of the basics, same thing with the MEP installation training, and having a virtual reality to do those introductory courses. We found out that I can work very well, and they're working with a local company now and creating some of those custom trainings for the skilled and trained workforce. And then of course using existing site conditions, just like a colleague talked about previously, using the open space, right, to document everything, and then being able in 2-3 years or whenever you got to remodel that building to lay over AR and to see where every pipe is. And just on that note, yesterday I did my first open space scan for the building. We've been using it for a while. I just haven't done it myself. So that was fun, definitely. So I think that was all for my presentation.
Well, thanks, Dusan. That was very interesting. My name is Renzo DeFuria, and I'm located in Seattle, Washington. And just a quick background for me, I've been working in the construction industry for my entire career since I got out of college, and I can split it into two halves. The first half, I was a project superintendent, specializing in self-performed concrete operations. The second half has been as a virtual model builder, specializing in fabrication tolerance modeling for self-performed concrete operations. And within that context, over the past 15, 18 years, I've developed a number of workflows, including model-based estimating, virtual storytelling for pre-planning, model-based surveying, laser scanning, drones, et cetera, including my favorite, which is digital fabrication with robots. And what I've learned implementing some of these workflows on hundreds of construction projects is that there's a huge potential for technology for sure, but it's really only leveraged if you can get it into people's hands and have them actually use it and be comfortable for to using the tools. And that's a pretty big kind of gray area of R&D that I spend a lot of my time in. You could call it R&D or applied research or prototyping. And so I'm going to talk about one beta test that I'm currently doing. If you can advance to the next slide, right? So I've been working the past few months with Trimble on a new product. I think they just announced it a week or two ago. I signed a non-disclosure agreement a few months ago to do a beta test, which we're currently doing. And that's using the XR10 HoloLens headset with a new product they're calling Trimble FieldLink MR, which essentially is connecting the total stations to the FieldLink software through the virtual reality headset, which is extremely interesting for me. So I'm going to talk about that a little bit as to why I think, first of all, that it's interesting. For me, doing a lot of fabrication models, my favorite way to get models into the field is through a total station. So I'm really obsessed with total stations and using total stations and getting 3D data into total stations and teaching people how to use total stations. And my belief is one of the gateway tools towards a digital fabrication master builder of the future is going to be through fabrication models and total stations. So that has got my interest to begin with. But then to add some of this VR or AR technology to it is pretty compelling. So try to explain it real simply. The FieldLink software, the Trimble FieldLink software is usually used on a tablet. They call it a data collector, and it's out in the field with the robotic total stations. You can do it with one man, do all of your layout. Now they're connecting that interface into your headset so you can actually see the software and manipulate the software with your hands, but you also can overlay the models and see the models as well. So that just adds some pretty interesting, I think, potential. So if you can advance the slide, I'll explain. I neglected to mention, I think we're 4 or 5 weeks into a 10-week beta test. And so the way we're working this is we do a session out in the field and take notes. And then later in the week, we meet with the Trimble developers to show the results. And we're just working on getting this process to work. And but I want to explain what problem I'm trying to solve with this particular beta test. So I've been involved in this new Seattle Aquarium construction for a couple of years now, actually. And we're getting very close to construction of the aquarium tanks. These are being self-performed by the contractor, so there's a lot of effort been going in to try to figure out how to build it. So this is a image of the tanks. The red circle is a detail. So I'd like to advance the screen just to show that detail real quickly, and then advance the scene again one more time to show the rebar behind it. So the rebar has been probably the biggest challenge and is really the critical path in the project because of its immense complexity, and it's the constructability issues to put this together have been pretty extreme, and we've been using fabrication level models to walk our way through all of those detail with the designers and the contractors and the fabricators. So we're very close to actually going into fabrication right now. But what I'm trying to do with the AR is two things: being able to use the headset in order to overlay the model in place, the rebar model in place. We're going to be doing that in sections as a QC step to see right there visually what we're supposed to be putting in place. And then as it's being erected, to continue to overlay and make sure that it looks like the model, but also with this very added amazing ability to use the robotic total station to verify measurements as well. So that's a real brief description of what I'm trying to do there. It's coming along very well. The tank is about to start and it's scheduled to be poured sometime in June. So very interested and excited to see this develop. And then I have one more slide because I have a second problem that I'm working through, which is this idea of teaching total stations. So as soon as total stations and layout, and specifically model-based layout. So once we finish this beta test, we're going to run through another series of tests to actually train people to use total stations, and we're going to use the AR headset to help with that training. So that's to come, but we'll be doing that in a couple of months. So anyway, that's my presentation. I'll give it back to whoever's next.
Well, thank you all for sharing all the knowledge and wealth that you guys bring to this table. I encourage all the audience to send any questions to any of the panelists directly, indirectly. You should have their emails. But in the meantime, I do see a question that was posed specifically to design. So maybe I'll have Dan kind of lead that answer a little bit. The question being asked is, are we giving too much power to our clients when we let them go into VR during design, letting them move things around? And is that the best solution at times? And I guess personally, being an architect, I have struggled with that at times, but I'll let Dan kind of speak about his experience with it. And
yeah, I think for us, it's a, we're always looking for ways to, both on costs on buildings, right? Can we reduce our floor to floor? Can we get another floor in? And so for me, being able to put a client in that space and allow them to play with it gives them the better understanding of like, oh, just squeeze the floor to floor, just keep squeezing. And then when you get in there and say, here's where your ceiling's going to be, and they go, ooh, that's too low, but I don't want to go back up to 14 feet. I want to be at 13.8. It does, in my mind, give them not necessarily, I think, the control, but the understanding of the decisions they make as they're going through the design process. But I don't disagree. These tools are tools. They are a piece of the puzzle of how we design. And just, I don't rely on them 100%, but I think there's some interesting ways that we can be more interactive with them.
It certainly makes the conversation much easier to explain sometimes, as far as when they actually feel the space, I think, especially when you talk floor to floor ceilings and how much of the ducting and all of those things take room. And I don't think they are able to visualize it. When you show them the model, they kind of get a better sense sometimes. So I agree with you. There's, like everything in life, there's pros and cons to each.
Correct.
So we have a couple more minutes. If there were any other questions for our panelists, I highly encourage all of you to come on, to add to the questions, or feel free to jump in. I guess while we wait for that, I did have one question for the panelists as far as the VR versus the AR. I know, we as architects and as designers, we've seen virtual reality come a long way, and much easily accessible, as Dusan was showing us earlier, that it's cheaper now, it's available now. There was a time it kind of was a fancy tool that can I afford it, but it's getting more affordable. But at the same time, is AR there yet? There's a little bit of lag, personally, I feel. So if any of you guys had any insights on how the AR technology is, progressing, or your experience with it.
Yeah, I think.
Yeah.
Go ahead.
No. You can answer probably better than I can.
I think that over like the next year, you're going to see a lot more AR coming out. I think that the fact that AR is so accessible, where all you need is a phone and you can kind of use it wherever. I think that's a big plus for it. And I also think there should be an AR VR headset from Apple coming out in the next year that should really probably push a lot of this stuff forward, where you'll be able to kind of flip back and forth between VR and AR with the tap of a button. So I think that should be very exciting as far as working with existing reality and bringing in new objects to it with the augmented aspect of it.
Yeah, I just wanted to hit on the technology that was talked about earlier. A lot of the, I think even things that Renzo was hitting on the construction side and the detail we put in our model. I still think there's a bit of an issue of our models. We build with a lot of detail, and it needs that detail, and for both the holistic use of the building, but is our computation, can the computers handle it? And it's maybe a push of a button, but it's like right now a Revit model, you try to get into VR that has everything in it, it just bogs down. So how does the technology, I think, still needs to keep moving for it to go to that next level?
I agree with you. We're almost on time, so I thank you all our panelists and all our viewers today to joining us. It was a great, interesting presentation and a conversation. I know I'm excited for a lot of things to try out that Rory showed. I'm already looking up those apps and seeing where can I use that with my phone. And certainly, all the construction industry that has come along, I'm curious to actually go out on site and see how these things are actually functioning. And, I've seen some bits of it, but it certainly is exciting. Thank you all. If you have questions, please reach out to our panelists. With that, I'm going to hand over to Lauren and Nicole for the end of the day.
Thank you, Janvi, and thank you for our final panel. It looks like we've come to a close at this year's conference, and I took some notes during this, and I'm going to share a few highlights from the sessions I heard today before passing it off to Nicole. First is that, in order to foster our design narratives, we should really look at the data of the projects. And buildings can be thought of as products and not actually projects. And data can help drive full building design as of today, and possibly even more in the future. Make sure that you don't start from nothing. There are many precedents in your own office that data can be utilized for. Buildings are not static things. They're always adapting, and digital twins can really help foster these changes. Utilizing existing standards for metrics, such as building or municipal codes or LEED, is an option. And to educate owners on new methods, demonstrating interoperability is key. So showing that there is flexibility within the models that we deliver to our clients. Digital technologies can help as delivery methods move more towards design build, and construction leans more towards prefabrication and industrialized construction. And as Janvi just said, as cheaper VR, AR options are developed and prices on technologies drop, more client and project incorporation will happen. So we'll see a rise in this likely. And both AR and VR can be utilized as virtual mock-up tools that allow users or owners to formulate their spaces or see how furnishings can actually fit inside their existing spaces.
Very promising takeaways, Lauren. Hopefully by now you find this conference isn't just about retooling and shiny new concepts and buzzwords, but also how technology plays a vital role in evolving professional practice by optimizing efficiency, expanding services, improving corporate citizenship, and of course, hopefully, increasing our bottom lines. Technology in practice is no longer limited to experts or big resources. Given the force of exponential change disruption in the marketplace, the firms with winning strategies, I believe, will and can make progress, not wait for it. If you're brainstorming how to get started or how to accelerate your existing capabilities, our speakers and participating sponsors have a lot to offer. There's also more to come this year from AIA LA, so stay tuned. As we close out, we'd like to thank our speakers, of course, for taking a time out and spending this learning with us, the conference organizing committee, our moderators, the AIA team who kept us together, Jessica, Corinne, Tibby, and Will.
Yeah, and also just a special thank you to the AIA LA Practice Committee. This event was created mostly by members of the AIA LA Practice Committee and our new technology committee as well. If you're interested in joining, as Brian said earlier, either of these groups, feel free to contact John V, Brian, myself, or any other organizer or moderator that was on this call. We're looking for new members and ideas, and happy to have you join us. So thank you all for joining us today.